Everyone's afraid to talk.
That awkward silence.
Yeah.
We're actually waiting for David
I
Eicher's
know.
new science-oriented Senate to take over sometime in the
Yeah,
future, and then we can
yeah.
start to talk again.
Boy, oh boy, we may be waiting a while, I think, for that.
A long time.
Mm. There's a little bit of science and a whole lot of nonsense in the Senate these days.
That Earth is not rotating correctly. I'm sure I'm not the first to notice that.
Yeah, they got the poll kind of mixed up here.
Like Miami's right on the equator.
Right. It's hot.
That's after the giant black hole passed through the
Yeah.
and tilted the Earth. It
Yep.
didn't rip it apart; it just tilted it.
The US just got warmer.
Either that, or the magma, or the core shifted around or readjusted itself somehow.
I thought that the inside of Earth was empty. Isn't that what they wrote about in the early 19th century?
Yeah, hollow Earth. Yep,
Yeah,
exactly. There's
yeah.
a whole nother civilization down there that we don't
They
know
were
about.
onto something. Exactly. Yeah.
And giant iguanas. Don't forget the giant iguanas.
Yeah.
Welcome back, Libby in the stars, and Happy New Year, Libby. It's good to see you again.
Happy New Year 2022, and it's already the 80th Global Star Party.
Yeah.
Like Libby's got a string of planets hanging off her ear.
They're just earrings with like little flowers on them.
Oh, it looked
I
like
wish they
little.
were
I
planets.
didn't see the
couldn't find
flowers.
planets. I have planet earrings. I couldn't find them.
This is as quiet as the fifth day when your in-laws are visiting.
All right. Yeah,
Waiting
you've run
for
out
your
of stuff.
Senate to
Yeah.
take over.
Right now, I'm sharing the beginning with some groups on Facebook, and this one will go to the Facebook Astronomy Club. There's quite a number of groups on Facebook as it pertains to space exploration and astronomy.
Mhm.
Oh, and Wendy is here, and you can all say hello to Wendy now.
Hi,
Hi, Wendy.
Hello, Wendy.
Hello.
Everybody, I'm listening. Yeah, she's listening. Thank you.
I'll use an online number generator then everyone can see it, Scott.
But you do get crushed by a singularity, and that kind of ruins your whole week if you go down through the event horizon of a black hole.
Oh, yes.
Not to, be beat up on sci-fi, but
Scott and I were talking about that earlier today on the other program. I think we were on the program. We were talking about it. We were talking about it earlier about what happens past the event horizon. And I think a lot of people that aren't into astronomy don't understand that there is a singularity. It's not just the event horizon. People seem to think that at the event horizon, that's the black hole. It is the black hole, but it's because it's dark, but it's the singularity that's the actual black hole, I think.
Yeah, the event horizon is just a distance, nothing more.
Right.
Large enough black hole, you'd pass through it and not even know it for a while.
yeah, a supermassive black hole, the center, as in the centers of galaxies, the G-forces would be undetectable. But then you get, toward the singularity and you're in big trouble. But a stellar black hole would be a wild ride even through the event horizon. Yeah. Either way, let's hope that's not how we end up. Okay. For our personal stories. Okay.
Could all have a spaghetti party.
Right. Yeah. I don't think we'd look too good if we were a string of protons 10 kilometers long, each of us, that would sort of.
So what's the relationship between the actual gravitational force stretching you out and the distortion of space-time? I mean, would you look normal to yourself?
Yeah, it's really just a question of the difference in percentage of the G-forces from your feet to your head. And if your feet are twice as close to the singularity as your head,
Right.
But
So there's
far
a
enough.
question in chat. Has anyone ever seen a black hole explode?
No, but we've seen we've detected the collisions of black hole mergers,
mergers.
right? Yeah.
Yeah, with LIGO, right?
Yep. And in fact, it was Kip Thorne and Rainer Weiss and their pals who did it.
I have this picture of the black holes when they merge. It's kind of like two billiard balls circling around each other, and then they just blop or something. I don't know how the matter fits, but it seems like they wouldn't knock heads or anything. They would just kind of merge, I guess. I don't know.
Gravity's too strong for a rebound, right?
Right. So it'd be cool if they were neutron stars, I guess they could bounce off each other. I don't know. Is that right?
There's a significant amount of energy transfer back and forth as the collision nears, but once they get close enough, you lose all, like you can't see what's inside that area of the event horizon. So all you see then is a featureless blob, like black holes have no hair. That's kind of the way we talk about it, is there's no external features to be noticed.
Hi, folks. They do it that way because they want to keep away from the insurance companies. Collision. They do it on purpose.
But from merging neutron stars, you mentioned, we get some of the very heavy elements, though, including gold, silver, platinum, etc.
Yeah, that's the energy transfer and the rebound from the collapse. Yeah, it's incredible what we are able to obtain off of it for signatures.
In 2004, NASA's Hubble Space Telescope changed astronomy forever when astronomers revealed the first ultra-deep field image. Created with more than 270 hours of observation over the course of a year, it is our farthest ever visible light image of the universe. This tiny window revealed thousands of galaxies in a seemingly empty patch of sky. We can't see any farther in visible light because the unrelenting expansion of space has stretched galaxies' ultraviolet glow into red light. More distant galaxies are mostly detectable in infrared. That's why, in 2009, Hubble captured an infrared ultra-deep field image that probed even deeper into the same spot. It remains one of the most distant images ever made, and a key source of information about some of the universe's early history. The Nancy Grace Roman Space Telescope will have infrared resolution and capabilities similar to Hubble, but each image will cover 200 times the area of sky. A potential Roman ultra-deep field could be far faster to capture, yet cover hundreds of times as much of the early universe. To further explore this potential, a team of researchers has created a simulated ultra-deep field image. The entire image contains about 1 square degree of sky, or about 5 full moons. Even a single Roman field of view contains a staggering number of distant galaxies, each one filled with billions of stars. This computer-generated image represents the distribution of galaxies that researchers expect to find based on the existing Hubble observations. It will help astronomers determine how best to conduct an actual Roman ultra-deep field and anticipate the measurements and conclusions they might be able to make. Because light travels at a finite speed, distant images are also snapshots earlier in time. Ultra-deep field images reveal a time from about 200 million to 1 billion years after the Big Bang. Roman's image would be the largest observation of its kind for this time period and could reveal key features in the adolescent universe, including rare infant galaxies that eventually evolve into mature galaxies like our own Milky Way. With Roman set to launch by 2027, this simulated ultra-deep field image is just one example of the fantastic results this upcoming mission could bring by the end of the decade.
Well, hello, everyone. This is Scott Roberts from Explore Scientific and the Explore Alliance, and this is our 80th Global Star Party. We have, as usual, we have a fantastic lineup of speakers, and the 80th will not be a disappointment for you. It is, the theme of it is the Golden Age of Astronomy. I guess there have been many golden ages of astronomy, probably going back over several hundred years now. But with the launch of J-West, the discovery of the expansion of the universe, just the discovery after discovery that astronomers have been able to make now with breakneck pace, we are indeed still living in another golden age of astronomy. So I'll be turning this over to David Levy. We had a very large audience watched our 79th Global Star Party. So if you're new and you're just now watching the 80th, or you just watched from the last Global Star Party, I want to say welcome. Thank you for watching from wherever you are in the world. We understand that, we're yet in another kind of crisis over the COVID pandemic. But we brought forth Global Star Party to share the excitement, the passion, and the love that, and the knowledge that we have collectively about astronomy to share with you all over the world. If you are watching on a platform that doesn't have that can't, you can't get to the chat box, you can go to explorescientific.com/live, pick one of our social media channels. A very popular one now is YouTube. Click on that one and you can see all the chats pouring in from all the different channels simultaneously. We will try to answer all the questions that we can. It's always a good time. So David Levy, for those who have not heard of him or have met him, that would be hard to do because he is, for so many decades, has dedicated himself to giving lectures, writing books, making discoveries of comets and asteroids, and sharing that with a worldwide audience since I think his passion starts when he's just a teen, maybe even younger than that. He loves poetry, he loves Shakespeare, and every Global Star Party, he encapsulates the spirit and flavor of each theme that we have. And he always has the perfect poem to go along with it. So David, I'm going to turn it over to you, man. Thanks.
Well, thank you very much, Scott Roberts of the Global Star Party. And it is really a pleasure to be here today. Wendy and I have really been enjoying these sessions, and we hope that this 80th will be up to the standards of all the others. Recently, we have formed a new group. It started out as the Denver Junior Astronomical Society, which is the rebirth of a group that I was a member of when I was a teen. And we've started that and then quickly expanded to our own club in Tucson, then to the Astronomical League, now to the Royal Astronomical Society of Canada, which Karim probably is well familiar with. And so at the last meeting, we were looking for a different name because Astronomical League or Junior Astronomical League seemed to be too much Americanized. We wanted to look up something that would have more of an international flavor. I came up with a possibility just the other day that I'd like to try out on everyone, to call our group Stargazers. And there's a reason for that. Of course, it's just two words, or one if you put them together. It is international because the word was originally put together in an English poem. And so it is actually, there's a little bit of a philosophy attached to this. If you go back to the English poem, which was written by William Wordsworth, or the young people in the audience would probably refer to him as Bill Wordsworth. Anyway, William Wordsworth was the poet laureate from 1843 to 1850. But long before that, he had some fun writing a poem called Stargazers. And I put it into my master's thesis, at which point when my thesis director looked at it, he commented that the poem was absolutely wretched. And I went into his office and I looked at him and I said, wretched? And the two of us just laughed and laughed and laughed. He thought that it was not one of Wordsworth's finer poems. But the more I think of it, the more I like this poem. And especially the ending, when he has people looking through a telescope and being disappointed. And a lot of them give up after that. It is my hope that our Stargazers group will not give up after you look through a small telescope, perhaps a department store telescope, and are a little disappointed by the results. So I'm going to read just the first and the last part of this so you can get an idea about the disappointing aspect of looking through a telescope. What crowd is this? What have we here? We must not pass it by. A telescope upon its frame and pointed to the sky. Long as it is a barber's pole or mast of little boat, some little pleasure skiff that doth on Thames's waters float. And then, yet showman, where can lie the cause? Shall I by implement have blame? a boaster that when he is tried, fails, and is put to shame. Whatever be the cause, 'tis sure that they who pry and pour seem to meet with little gain, seem less happy than before. One after one they take their turns, nor have I one espied that doth not slackly go away as if dissatisfied. I know we have a lot of young people here at the Global Star Party, including one who is with us on the live Zoom aspect of it. Libby is back. We'll be hearing from her a little bit later. And I hope that you will all join us when we have our next meeting of stargazers over Zoom on January the 30th. If you're interested in attending, you can write to Scott and he can send you the link when the link becomes available. And on that note, I shall now hand things back to our director, the beloved Scott Roberts.
Thank you very much. Thank you. We are we're honored to have people of young and older. I think everybody feels young though as an astronomer because it's exploring the universe makes you kind of evergreen. You are constantly witnessing something new. It's always live. When you gaze back into the cosmos with your telescope or just with the naked eye, every time I see a beautiful bolide streak across the sky, I can tell you that I feel it's almost like a rebirth of a sort because it's just so exciting, and that you are somehow flying through space and involved in this great and grand adventure that we're on as the only animal on our planet that is trying to make sense of our universe, as far as I know. Anyhow, up next is the editor-in-chief of Astronomy magazine, Dave Eicher. Dave Eicher has spent his life writing about astronomy. He has been involved in all various aspects of promoting astronomy and studying the sky. His roster of colleagues, friends, people that he's rubbed shoulders with goes many light years. If you haven't been involved in the amateur astronomy community and haven't heard of Astronomy magazine, I would say that that definitely, again, is a rarity. Astronomy magazine is one of the big authorities on things going on in the sky, things going on in our community, and has been driving the amateur astronomy community for many decades now. And so we're really proud to have David on with us. He, during the last Global Star Party, he recounted his trip to Antarctica to see the eclipse, which was awesome. He is now back to talking about his incredible mineral collection. So, David, I'm going to turn it over to you, man.
Thank you, Scott. And I'll be doing a little more planetary geology tonight again and share my screen. We'll see if this works again, and I'll see if I can put this into the slideshow. And tonight I'm going to talk a little bit about copper minerals, one of the more common and also more interesting classes of minerals. We're kind of working our way through some mineralogy here, which shows us how the universe likes to form planets. This is a tanzanite crystal here, of course, just as an opener, which I've had in here. But what's interesting about mineralogy is it shows us how matter comes together and forms not by magic, but by science in the universe. And these days, in certain places in our world, we need a little more science and a little less magical thinking. I think it's fair to say, at least from my point of view. So Thomas Jefferson, though we may admire him in many ways, wrote, I believe, in a divinely ordered universe. Even before Jefferson's time, Isaac Newton, one of our great heroes, wrote, the truth is ever to be found in the simplicity, not in the multiplicity and confusion of things. Well, he was right about that. The universe, it turns out, is ordered not by supernatural design, but by the simple principles of physics. And of course, not understanding those principles for many, 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 many years led to a lot of ideas about supernaturalism. Minerals demonstrate the natural world and how it actually works. And by that, I mean physics and chemistry. Their atoms are assembled in precise ways by electrochemical attractions, inherent properties of the atoms that make them up. And these are guide them into assembling in a very specific way, in what mineralogists call a crystal lattice. So the available atoms that are there at the right pressures and temperatures and so on come together and they form minerals in a straightforward way, simply by following the laws of physics.
I can rename myself.
Uh-oh, someone needs to rename themselves. Are we good? Okay, we're good. Okay, so let's talk a little bit about copper tonight. It's a native element, of course, not a compound or combination of elements. The abbreviation is Cu. It was one of the first metals to be worked into implements and the first metal on Earth to be smelted in Anatolia, what's now Turkey, about a little more than 9,000 years ago. So people have been working copper for quite some time now, of course, which led in part to, among other things, to the Bronze Age, which was a big step forward in creating tools and the technology to do things in civilization. It's red in color naturally, but as you know, as we've talked about before, oxygen, what does oxygen like to do? Oxygen really loves to interact with other elements. So it oxidizes things like copper that are very susceptible to it and turns copper green or black with exposure to air. As evidenced by the things like buildings, roofs of buildings and the Statue of Liberty and all kinds of fun things like that. Well, the term copper comes from the Greek Kyprios, which means of Cyprus, which was where the earliest copper mines were discovered, and in Latin from the word cuprum. It's a member, surprisingly enough, of the copper group, which consists of a whole lot of minerals related to copper. And it combines with numerous other elements to produce many mineral species. And so I just wanted to show sort of a selection of copper minerals that I pulled out and took some pictures of. And you can see the kind of range of what copper contributes to. Your house is full of copper, of course, in all sorts of ways, electronics, pipes, et cetera, but it's really good for mineral collectors as well and interesting. The crystal structure of copper is isometric, which is a term we talked about a couple of weeks ago, which simply means cubic, fancy word for cubic. And here's a schematic diagram of the crystallography of copper in a cubic crystal lattice. And I'll just show a few examples of copper minerals. Now, this is copper with cuprite. Well, again, oxygen likes to react with things like copper. So this is cuprite is just copper oxide. And this is a nice example of a native copper piece that has oxidized a little bit from the Dripping Springs Mountains in Arizona.
Hey, David, I just
Yes.
had on my desk, I got a sample of some copper
nice.
here.
Of native copper. Can you get that a teeny bit closer? There you go. That's a great view of it. Yeah. Awesome.
So that came from the Caledonia mine in Ontonagon County, Michigan, I guess is where it is.
Yes, the Michigan Peninsula. More copper, especially up until about a century ago, after the ancient mining of copper, more copper in the modern era until some decades ago now came from Michigan than anywhere else on Earth. Michigan, the Michigan Peninsula is extraordinarily rich in copper. So here, that's a nice example, and thanks for showing that, Jerry. This is copper pseudomorphed into cuprite, which again is oxidized copper from Russia, and it shows you the nice little crystallization. And you can, although it's a cubic form of crystal, you can get little distortions of the cube, and you can see these little angled crystals here in this specimen here that take on various shapes, geometrically pieces of cubes here in this sample from Russia. Here's a native piece going right back to the Michigan Peninsula, the same place where you have your specimen from, Jerry. That's about a 6-inch wide piece of native copper crystals from there. And I like to, I don't know if you can see why, but I like to call this piece the rabbit. Maybe I was up too late, taking pictures of this. I don't know, but it sort of looks, running to the left there. I don't know, it's like seeing a constellation figure, isn't it? Who knows? So that's a native copper piece from Michigan. Copper atoms can also crystallize inside as inclusions in other minerals. This is calcite, also from the Michigan Peninsula, and there's copper inside these calcite crystals. You can see at the center and on the right-hand side of this specimen that colors it coppery red color inside the calcite, which is a very common mineral. Now we're getting to a little bit fancier things that involve copper. This is bornite, which is a copper iron sulfide with some silver as well. There's a very famous region of copper and silver in Mexico, the Zacatecas area down there. And this is a sample of that. So you can see some sort of different looks. And even after this crystallized, you can see oxidation on it, which gives you this sort of rainbow iridescence on some of these metallic specimens like that. There's also a fairly simple mineral, a copper mineral called chalcocite or chalcocite that is copper sulfide. These are crystals of chalcocite on quartz from Kazakhstan. That's a fairly common mineral as well. And then here to show you the differences of what oxygen can do to various minerals. The next three are all chalcopyrite or chalcopyrite, copper iron sulfide. And this shows you one that is oxidized after it formed into this sort of peacock iridescent colors here. And this is the very same mineral, the next three from the very same mine, but with sort of different appearances here based on the oxidation of things. This is the same mine and with this intense sort of rich blue color of oxidation, and then the very same mine, same mineral with this sort of brassy gold color. So you can see the differences that oxygen makes interacting with various minerals as well as other things on Earth. Azurite is one of a couple of interlinked copper carbonate hydroxide minerals. Azurite and malachite together make up a large part of the copper carbonate hydroxides, and you can see the formulae there. This is an old specimen that my father collected with his family at Kennecott, Alaska around 1930, and it sort of looks like a sort of a brain, and you get this very rich blue and green colors in a lot of minerals from the copper content in these crystals.
Beautiful.
Thank you. Here's a more recent modern Australian azurite specimen, the rich blue that almost looks sort of like a flower with the crystallization on a sort of a dull white mineral that's called kaolinite. That's not very spectacular, but this comes from a copper mine in the northern part of Australia. Very nice azurite quality. And then there's a lot of azurite and malachite. Well, it comes from lots and lots of places, but a famous place of recent vintage is the Milpitas mine in Sonora, the Sonoran Desert of Mexico. And this shows you a sample of both azurite and the greenish malachite together there. That's, as you can see, if you want to, from the formulae here, a very subtle difference in the amount of copper as the difference between those two minerals. This is a kind of cuprite called chalcotrichite. Let me try that again. Chalcotrichite. It's been a long day at the office. And this is very unusual, this Chinese specimen, which is just copper oxide, because it forms these needle-like crystals you can see there, or what mineralogists would call acicular crystals, like needles. This is a rare mineral that's quite unusual and an old specimen and fairly valuable, called lyriconite. That's copper aluminum arsenate hydroxide hydrate. You can follow the formula along there. That is copper aluminum arsenate hydroxide with a 4 water molecules stuck to it. So there's a lot of stuff going on in there, and to produce this sort of beautiful peacock blue that is treasured by collectors. And this is from a number of old mines that are defunct in Cornwall, Land's End, England, most of these good specimens. So that one's quite an unusual one. And then I thought I would finish off with a sort of a spectrum of the blue and green of this mineral, chalcoalumite, which is a copper aluminum sulfate hydroxide hydrate. Some of these get to be, you know, formulae, the complex minerals as long as your arm. But this is an interesting copper mineral as well. And it comes from the Grandview Mine, Horseshoe Mesa in Arizona, which is actually adjacent to, or maybe even within, I'd have to check it again now, the Grand Canyon. So this is mineralogy from, maybe not in the national park, but from the Grand Canyon itself, this mine, which is interesting as well. So that's sort of a quick tour through some of the bright and interesting kinds of forms of minerals that you can get from copper, one of our most useful elements on Earth. And shamelessly, once again, I will mention that Michael Bakich and I, a few months from now, have a Child's Introduction to Space Exploration book, is the next one on the launch pad, coming out later this year. So that one will be good and inspiring, we hope, to kids. And I will stop sharing my screen, and Scott, throw it back to you.
Yeah, I was curious also, David, what we can expect from the next issue of Astronomy magazine.
There are several special things we have coming down the pike in astronomy, and there are a couple of sort of regular issues, if you will, coming up. But there's a very special issue that kind of leaked out a little bit, and so I figured, well, you know, I might as well talk about it. A few issues from now, we have a unique issue that's coming out in conjunction with Aldo Spadoni and some others who are the officers of the International Astronomy Artists Association, the IAAA, the art group. And we're going to have, the entire issue is going to be devoted to what the current pulse of astronomical art will be. Solar system, space exploration, the Milky Way galaxy and stuff in the galaxy, galaxies and deep space and black holes beyond, the whole spectrum. There'll be 50 art pieces that have never been seen before in this special package, with some special essays that talk about this art and the people who do it, how they came up with it, and what it's showing us, and still, you know, taking us to places that we can't go despite our great photography. You know, back in the old days, Steve Walther, who was the founder of Astronomy magazine, and it reflects the early 1970s. It's not meant to be misogynistic, but he used to say that the magazine, it's man's dreams of worlds unseen, was one of the slogans of Astronomy.
I love that.
And this art is taking you now, still, even with the space telescopes and the huge ground-based telescopes we have, and the coverage in larger parts of the spectrum than we've ever had. Still, the artists, and we have a very famous one with us here online.
That's right.
I don't know if I'm
bring him
supposed
on
to
for a
reveal
moment.
that yet, but
Here we
these
go.
pieces of art, like Mike Carroll can tell us better than anyone else, can take us to places that we can't journey to. And that's really a critical thing for us to be able to embrace and imagine those worlds, isn't it, Mike?
Well, yeah, that's it's certainly one thing that we try to do, a lot of the data we get is numbers. And those numbers get turned into some of these beautiful images that we see coming down from Hubbell and Cassini and all these other things. But there's a lot of non-visual data that the artist can take and translate into something that folks can understand a little better. So it's a privilege to be part of that project. I think it's neat that astronomy is showcasing so much of that art coming up. I'm looking forward to seeing the issue.
David,
Well,
I've got a question, David, if you real
Yes.
quick. Do you talk anything? Do you have an article about the future of virtual reality and art and space science and stuff like that?
Absolutely. We do have some, I don't want to reveal the whole year's plans, forgive me. But
Right.
we
right.
do have some things coming down the pike like that, and two big special packages coming toward the end of this year as well, which I won't get into. It's a little too early for those. But yes, we will be talking about some of those things, Jerry. And Jerry and David and Mike have all written for the magazine, and Scott, you must have too, I think. Mike for many years has written story. Mike has a piece that he's writing right now for us that will appear a little bit later this year as well. So, just let me say one related thing, if I could, for 1 second. Last year I had the good fortune for the first time ever to go to Space Fest in Tucson. And that's a meeting that is really the artists' meeting, and where the artists show up and they show their stuff once a year in Tucson during the summer. And there's really nothing like that. Mike, I don't know if you want to say any more about that as well, but Kelsey and Poor and Sally Poor put that on in the tradition of Kim, who started it. And that's really a special meeting. If people have the chance to go to Space Fest and see 30 or 40 or however many it was, artists all showing their stuff, that was really an eye-opening occurrence for me to go there, and inspired this issue.
Oh yeah, it's a pretty amazing get together. And they also have the majority of the moonwalkers there. Lots of great speakers, science speakers, and so it's a really neat get together.
It is. You can have astronauts, sign your books and programs and all that kind of stuff too. I had the amazing experience running into Charlie Duke for the second time in 2 months, who actually said, Dave, and usually you have to say Charlie, and so that was kind of neat, but yeah, it's a tremendous thing if you get the chance to go to Space Fest, and I hope that they'll be holding one this year. I don't know what the plans are exactly.
Oh, great. Well, I have posted the Nova Space Gallery webpage, and we have had people from Nova Space on our program before, and with some guest artists, but it is tonight is the first time to have Michael Carroll bless our Global Star Party, and so he wanted to check it out and see what it's all about. So hope you're enjoying it, Michael. Okay, so up next is our segment with the Astronomical League, and joining us tonight is Chuck Allen. Chuck Allen is an amazing astronomer in his own right. He is definitely someone that has inspired us with his talks on distances and scale and incredible, the processes of things that go on in our universe, from the big to the small to just the cataclysmic. It's really his programs are interesting, on point, accurate, and inspiring. And so I think everyone loves when Chuck Allen decides to give us a presentation here on Global Star Party. Tonight, he will read off questions from the last Global Star Party, which was our 79th. We are doing a special prize because this is our 80th Global Star Party. We're going to give away, Explore Scientific will give a $500 gift certificate, and Chuck will explain more.
Okay. Scott, thank you very much, and good evening, everyone. I'd like to add something to David's talk on minerals. I've always been fascinated by minerals myself, and never missed the mineral display at the Smithsonian. Anytime I go to Washington, I'm sure he doesn't either. Back in 2002, I went on a mountain climb in Colorado and came back through Moab and went to the rock shop in Moab, which is quite impressive, and made the mistake of handling a piece of pitch blende, which cost me 7 TSA agents at the airport in Salt Lake City and 2 hours trying to get on the plane. Never could get past the radiation alarms, even though they cleaned the wand about 7 times, I think, during that process. So beware the pitch blende. Anyway, tonight we have, I'm going to share screen now, and we will start with something that is of particular importance, I think, for all of the younger observers out there who are getting started in astronomy. And it's something that we like to emphasize because solar observing can be done safely, but you cannot make any mistakes observing the sun. And one momentary mistake can cost you permanent eye damage. And so we like to help people avoid that. Obviously, you don't ever want to observe the sun without professionally made solar filters that include energy rejection filters that go at the front end of the telescope, not over the eyepiece. You don't want to leave a telescope or binoculars around where children might attempt to use them to acquire the sun. You don't want to use non-certified eclipse glasses or viewing cards unless they comply with ISO standards, international safety standards, and certainly never use eclipse glasses with an optical instrument. They're meant to use with the naked eye only. And Scott, I think, experimented one time with some eclipse glasses at the eyepiece of a telescope aimed at the sun, and they melted rather quickly, as I recall.
Yeah, I saved my eyes, but yes.
Yeah. So don't make mistakes with the sun. Contact people at local astronomy clubs in your area, because many amateur astronomers are skilled solar observers and photographers and can tell you how to do it safely. Okay, let's go to the answers from January 4th, the GSP. First question was, what is the name of the tool used by astronauts that combines a pair of pliers and a wrench? And the answer is plench. Okay, question 2 was, which 4-letter word beginning with N is a star, showing a sudden large increase in brightness, then gradually returns to its original state over a period of weeks to years? The answer to that is a nova. And question 3, selenology is the scientific study of which celestial body? The answer is, of course, the moon. Okay, here are the correct answers from January 4th. These names were added to the door prize list for the month of December. I'll let you just take a look at the names rather than read them all here. And now we'll move on to the winners for the month of December: Billy Beckett, Mateo Castro, and Connell Richards. Okay, I want you to remember those names. Billy will be number 1. Mateo will be number 2. Connell will be number 3. And I'm going to stop sharing right now and reshare my screen with a random number generator that's set for 0 out of 3. So you can see the number change, and I'll go until we hit either 1, 2, or 3. And the number we hit is number 2. Mateo, you have just won a $500 prize generously donated by Scott Roberts. And Scott, thank you so much for adding that tremendous prize to the door prize process. It's really wonderful of you to do that.
Thank you. Thank you. It's an honor for us to do what we can to support the astronomical community. So it's something that everybody in our industry should do as much as they can. So we are now going to, before I go away, I do want to we're in the middle of this. We still have more to go, right?
Yeah,
You
we
have
do.
to-
I've got to do the
Right.
questions. for
Okay.
tonight.
The segues on to it.
Sorry about that.
Bye,
Okay.
everyone. That's right.
There will be no
That's right.
questions for
Yeah,
GSP
that's right.
80.
That's right. So now we have new questions, right?
Yes, we do.
Okay.
Okay.
And they go to your answers go to secretary@astroleague.org. I'm posting that into chat right now.
And it appears at the bottom of each slide, secretary@astroleague.org. First question tonight. This 72-inch telescope held the record as the largest telescope in the world for 72 years, until the 100-inch at Mount Wilson went into operation in 1917. In what country is this 72-inch telescope located? Picture on the left. Okay. This is the second largest moon in the solar system. Is it Earth's moon, Ganymede, Titan, or Charon? And the third question. This galaxy is a record holder. What record does it currently hold? Is it the furthest known galaxy? Is it the largest known galaxy? Is it the furthest companion of the Milky Way? Is it the fastest rotating galaxy? Or is it host to the largest known black hole? And again, send your answers to secretary@astroleague.org. Also, please remember that on Friday, January 21st at 7 p.m., we will have our next Astronomical League Live, which again will be hosted through the courtesy of Scott Roberts on the Explore Scientific platform. And we'll have more information coming soon about our speakers for that program. Scott, thank you very much again for your time, and good night.
Thank you. Thank you. If you are not yet a member of the Astronomical League, you should consider joining. They are a fantastic organization, as I've mentioned many times before, but I guess I can't mention it enough. The Astronomical League is the world's largest federation of astronomy clubs. They are a collection of over 300 clubs and have over 20,000 members. They have an incredible lineup of observing programs, award programs. They, I think, represent the community in the very best way, and you'll get a lot out of it. So join the Astronomical League. All you have to do is go to astroleague.org and go to the join page.
So actually, I have a question for you, Chuck,
Yes.
before you go on, Scott.
Yeah.
We have members that are wanting to join the Astronomical League. Normally in our club, we renew after June 30th of the year. Can you join the league before that?
As a club?
As a club? Or should we wait until that date?
No, the dues are prorated depending on when during the year you join.
Okay.
So you're not going to end up paying a full year's dues for 3 months or anything like that.
Right. Okay. So and
That's
it
just
starts
our-
over in
Yeah,
July.
it
July
does.
1st.
So
Okay.
if you join late in our fiscal year, then your dues will be prorated for that period.
Okay.
Yeah.
Thanks. That's what I wanted to know.
Sure.
Great. Well, up next is one of our youngest presenters, Libby, who's known as Libby in the Stars, has given over 50 presentations to the Global Star Party. She lives locally in Arkansas and has visited our offices at Explore Scientific. And she is someone that is so enthusiastic, so on fire about astronomy and space exploration that I think she's read every book in her library about the subject. So, and I don't mean just her private library, the school library, and I think maybe the public library locally as well. Libby, it's great to have you back on. How are things going for you?
Things are going good. I'm wishing everybody a happy new year. Even though it's kind of late. It's not happy. It is the new year, but it isn't New Year's Eve. But to everybody, happy new year. I made a presentation, so I'm going to go ahead and share my screen. So in the following that we are doing the Golden Age of Astronomy, I decided I would do a presentation on the space shuttles. Because one thing that has always made me kind of just more interested in the space shuttles is that they land like an airplane, and they kind of have the same design as an airplane. And my friend, one of my good friends, her dad, flies in an airplane, one of those little wing ones, and recently got to ride in one of them. And since then, I've just been like researching just space shuttles, just because they're so like, they just are in the same kind of family as airplanes, even though they don't go the same places as airplanes. So I'm gonna put in a slideshow so you can see a little bit better. It's taking a while to load.
Libby, you've seen a space shuttle up close, right?
So yes, I've seen Atlantis and Kennedy Space Center when I saw the Falcon 9 launch, and I've seen one that was for testing that isn't really known as a space shuttle. But it was there as one to do measurements for NASA. So the space shuttle program started after the Apollo launch in 1969. NASA was like, "Woo! We just did the space race. We just went to the moon. We're on a roll. We need to keep this going." And so NASA was thinking in their office, they're like, "We want to launch more people and stuff," like how they were doing, but they were thinking of being it since they were launching so many people and they had all these pieces left over. They were like, well, we're leaving all these pieces and it's not really that good for the Earth, so we need something that's more reusable, so we're not Earth and money, because a lot of this stuff was expensive. And so NASA just decided that they needed something to reuse over and over again, so they can make multiple trips out to space and stuff without having to build a full other rocket and spending a bunch of money. So Enterprise is the first space shuttle. So I was really intrigued when interesting, like researching this one, because like in the picture you see that it's flying like an airplane, and so I was like, it's flying like an airplane, which all space shuttles do, but it wasn't in space. And so this actually reminded me back at my space camp trip. They were talking about how when I was doing this research, how this space shuttle wasn't equipped with heat shields, which are like that kind of tile look. It's their little tiles, and I've actually seen them before, because at the museum in space camp, we would go there a lot, and I remember there's this huge wall of these little space tiles, and I was like, space tiles, huh? So I remember they're for keeping the space shuttle warm, because of course you can't go for the atmosphere without being burnt, because that would not end up good, because the atmosphere is so hot. And so this one wasn't equipped with heat shields, so it couldn't go anywhere except just fly through the air. And I was thinking, imagine being on a commercial flight a long time ago and seeing this flying through the air. And you're like, wait, that's supposed to be in space. You're like, oh, it's supposed to be here. That's supposed to be in space. So I kind of got like, I was like kind of worried. I was interesting. I'm like, why is it in midair? It doesn't have heat shields, nor those space engines that are really strong to get for the atmosphere. And so this is a test space shuttle because they used it like that. So Columbia was the first one to actually get, into the air. And so it was named after, of course, the first ship to navigate the North American Pacific coast. And so when I was researching this one, they said this one had a lot of more different qualities than the other space shuttles, because it was a lot more, it was like really, really heavy. And so I was wondering, why did NASA do this? And it was easier to dock with more with the ISS. So it was with all the space stations, they could carry people to and from the space stations how they wanted to, which is making it reusable with the space shuttles. Sadly, on its last trip, it disintegrated with astronauts inside during re-entry for the atmosphere. Then the next one is Challenger. And the funny thing is, at school, our team is called Challengers after the space shuttle. So all the hallway decor is after Challengers, and we have all these space shuttle themed stuff. So I kind of was cool, like really interested in researching this one because my school's team is named after it. So after a while success for NASA, tragedy happened. But sadly, NASA, the sad thing is that 72 seconds after launch exploded, and the 7 crew members inside did not survive. But NASA decided to learn from the tragedy and kept on going for the space shuttle program. So Discovery is the third one, and over 27 years, it launched and landed 39 times, which is why NASA was talking about making it reusable, because they needed to go so many times up and down. And so this is more than any other spacecraft do to date, more space flights, which is crazy. So you're telling me this thing launched 39 times, launched and landed 39 times successfully. So NASA was on a roll with this one. And so this one was one of the most successful ones, of course, because I was able to go up there a lot. This space shuttle has 3 main components: a space shuttle orbiter, which is kind of like the hard shell, single-use gas tank, which they were able to switch out, 2 reusable rocket boosters, and almost 25,000 heat-resistant tiles to help the orbiter when re-entering the plasma hot atmosphere. So more of these heat-resistant tiles were used in all of this. So that was one of the most successful ones. So I've actually seen Atlantis before. I went to Kennedy Center in Florida once to go see a launch because I was just like so excited. And it just started raining. And so I remember we had to take shelter inside the building because it was just so wet. Walking into the building, the Atlantis space shuttle is there, and I'm just like, oh my gosh. I'm like, this is possibly the best place where you could take shelter from the rain. And I remember I was just in the Space Museum, I was looking up at it, I was like, oh my gosh, it's so huge. I mean, truly, these things are like ginormous. And so this is one of the ones that I have seen. And this is another successful one. Atlantis had orbited the Earth a total of 4,848 times, traveling nearly 126 million miles, or more than 525 times the distance from the Earth to the Moon. Which, talking about the Golden Age of Astronomy, just a little bit ago, we were making one trip to the Moon, one big step for mankind, and then maybe a decade or 2 decades later, we're traveling 525 times that with the space shuttle. So that's improvement. And that's what I really like researching is we're improving every day. NASA is making more discoveries and their lab is always onto something else. And so we're in the golden age. Of course, is this the topic of the star party that we're doing tonight for the 80th. But we are in the golden age of astronomy because, I mean, a lot of people don't know it, but I mean, there's discoveries being made every day and different stuff and different topics around the space. And so just thinking like that one year we were like, one big step for mankind. We made it to the moon, and then the Atlantis space shuttle is traveling nearly 525 times more than that. So that was Atlantis, and it was one of the really successful ones. So Endeavour was the final one. So after a loss of Challenger, NASA was like, well, we need a replacement one because we're doing so many space missions. So NASA built Endeavour. And while I was researching this, I saw that NASA ran a competition for schools around the country to name the space orbiter. So all the kids around the schools around the country were able to name this Endeavour. And it had to be named after a research vessel and easily understood as a space name. So I researched where all the remaining space shuttles are on the map, and I put them on the map. So I know I've seen Atlantis, and there's one at Space Camp that they use for measurements that I can't exactly remember its name, of course, the one time I need to. But I have seen Atlantis, and it was just so huge. And I remember it was so much fun to see. And they had a fake one standing outside that was for show. And I remember I was on the bus from my resort over to go to the Kennedy Space Center. I'm like, oh my gosh, it's a giant space shuttle. It was huge. And I was like, oh my gosh, it's huge. And outside, I went inside, and the building is so big. And I'm like, it looks so tiny, cramped in here. And seeing the science of how the doors open on top was so cool. And I was researching it, and I was like, you could just open the doors, fresh air. Even though you're only going to be looking out at the gravity space. So, as you can see here, they all are. We have Florida on the coast of Florida, Endeavor's all the way on California, Enterprise and Discovery is the remaining ones. So, I'm going to stop screen share. And there you go.
Yeah, I've been to the Udvar Hazy Museum, Smithsonian at Dulles Airport. I'm real close to that, so I get a chance to see the shuttle a lot. Every time I visit there, that's a special place to go see the Discovery.
Yeah, I definitely plan to go back to Kennedy soon, because it was just so much fun seeing that. And I love researching rockets, but I thought the space shuttles are so cool because the doors open up. So it's just like the technology. I'm like, how does everything inside not fly away? But then I'm like, oh, Velcro, Velcro and everything. But
the nice thing about the Discovery display at the museum is they have all the other space capsules next to it, and it really floors you when you look at the size of the capsules, even the Apollo capsule, and then you look up at the space shuttle. It's so huge compared to these tiny capsules, and we jumped from the capsule in Apollo up to that huge machine, and you wonder why can't we still do that, and that's what Elon Musk is doing with the Starship.
Yeah, and what I forgot to bring up is the way they land too. The space shuttle comes in on this really long path. I remember in NASA TV, I was watching a segment where they were talking about really how long this road is that the space shuttle lands on, because it's coming in like 100 times more stronger than a commercial airplane flight. And it's going to take so much longer. Meanwhile, the capsule has the parachutes that deploys time after time and that land in the ocean. So there's so many different ways that it lands, and then also how long they have to make this pathway for it to land so it's not running off the pathway. So there's so many differences between the capsule and then the space shuttle.
Yeah, I remember seeing the last space shuttle launch, and it was incredible to see that thing leap into the sky, even at a distance of several miles, to see this thing the size of a skyscraper jump into the sky and fly off was just unbelievable,
Yeah, when we were at space camp, we learned about the space shuttles and, little hacks, like not hacks, but, like how they were built and stuff that NASA thought about. And it was like, but wait, why is the back tank red, or like this kind of orangish red color? And they were like, because my first year at space camp, they're like, it's so that they could, know, because they had to release it after a while. That was the gas tank, and they needed to sell the difference, because usually everything that NASA makes is the color white, so you can see it easily. but they had to make the gas tank like a different color that held all the rocket fuel. And I was just like, they could have made it. They could have, they could have chose pink. They could have chose green. They could have chose yellow.
I'm sure there's a lot of thought that went into it. So,
And
Yeah.
I thought the very first Columbia launch, it was painted white.
Yes.
And
It
then
was.
Yeah,
as
it was
they,
painted white.
and then the subsequent launches, it was orange. And someone, now this, I don't know if it's true or not, but I also thought something about the cost to paint the
Well, it's the weight. It
booster.
was the weight. They were trying to save weight. So
Okay.
they didn't paint. That's just the raw color of the installation.
Yeah.
Yeah.
So that I knew there was a true answer and not the money spent to paint being the answer, but I knew there was some reason they decided not to paint it, and the weight makes a lot more sense.
yeah. Well, great. Well, thank you very much, Libby. It's good to
you.
see you on the show again.
Thank you for having me. It was really nice to be on here.
You're always welcome. Thank you very much, Libby.
Thank you.
Up next is Jason Guenzel, the vast reaches. You'll see him on Instagram, Facebook, on various social media channels. He has a huge following. He makes some of the most incredible astro photos I've seen any amateur astronomer do, and he is known for squeezing every last ounce of performance out of the equipment that he owns. Jason, thank you for coming on tonight. Are you getting some live views through your telescope?
That was the plan.
That was the plan. Okay.
It's not really working out according to plan. So yeah, I mean, but it's I guess a good demonstration for people. It's not all roses when you get out there and set up your equipment. Oftentimes, Mother Nature gets the best of you, and that's what happened to me tonight. So my original plan was to set up my telescope and collect some data, while we sat here and hopefully come up with an image. But I literally can't get my telescope to track across the sky because the atmosphere is so unstable. But I always have stuff I can show, so I think we'll just kind of wing this. So let's share a screen here. Let me know when you can see it.
Yes.
All right. So before we step off the live imaging thing, I just figured I'd show a setup. It's not running right now, but this is the control software I use for imaging. And you can see there in the background, that's an image of M1, the Crab Nebula in hydrogen alpha. I shot that. It's the only image I was able to get today, but I just walked outside and snapped this picture, and you can see that the sky is covered in clouds now, and it's very windy. But so this is like the command central. When I'll go out and image, I put a list of targets here in this main window you see here. I've got a few targets in here queued up. And then I can connect all my equipment. This software is called Sequence Generator Pro, if you haven't seen it, but I connect a camera, a filter wheel, a focuser, a telescope, and these boxes over here. And then for the night's imaging, I'll program a sequence, which is just a number of exposures to take per image, what filters to use, and how long the exposures are. So you can see that down here. I've got a sequence set up with 7 steps using 7 different filters, different exposure times, different, actually there's a different camera gain too, but that's not shown on this screen. But yeah, so this allows me to automate the process, and essentially, once I hit go on this software, as long as the conditions are decent, this thing will run all night, with just a program list of targets. It'll even switch targets as some become obscured or set or otherwise not imageable. But that software then is keyed into guiding, which I use PhD 2 here. And this is just shows the tracking. And this is actually taking pictures here, but you can see how this line should be a flat line on a good night, and it is completely wild tonight. So it's really breezy out.
So that's a function of both the clouds and the wind knocking the kind of
Yeah,
blowing the
well,
telescope off its
actually,
guiding.
the third factor here, which I don't want to get too technical into it, but when you're imaging at a longer focal length, which this setup is, that's shooting at about 1500 millimeters.
Oh, yeah.
The atmospheric seeing is a big factor, and seeing is just the
Yeah.
stability of the atmosphere, the column of air you're looking through. And similar to how looking down a hot road in the summertime, you'll see the heat waves coming off the road. Those heat plumes and waves exist in our atmosphere all over the place. And as you stare through, the entire thickness of our atmosphere, this turbulence and disruption becomes visible in the image. And seeing is variable, both by location and just at different times you'll get different conditions. The jet stream is a huge factor in creating poor seeing, but generally if you've got decent seeing, you get real stable images, you get crisp point-like stars. If you look at this image I have on the screen here, these stars all look a little bit soft. They almost look out of focus, and it's not a function of the focus. It's actually the blurring that the atmosphere is causing as you're looking through it. I actually pulled this up because I wanted to see. So this is the image I shot tonight over here on the right-hand side of the Crab Nebula. And this is the same image shot on a different night. Actually has the date here. It was February 9th, 2021. So almost a year ago. But you can see here in these images, the difference in the detail and the crispness of the stars. I mean, all these stars here are points. You can actually see the filaments in the nebula itself, which is all blurred out in the image I took tonight. So on a night like tonight, I wouldn't even generally bother, although I set it up just to try to get some images. The background here is, these images behind, these are the core of the Rosette Nebula. It's something I was shooting last night also. So I pulled those up just to show you what quality single images look like, because the one I took tonight is not good. All right, does anybody have any questions on that imaging side of it? I'm not going to spend too much longer.
Right now, not yet. Not yet.
Yeah, I had one other question, but I think it was more of a just that's cool to know. You have the different filters selected, and the software automatically controls your filter wheel and puts the right filter in, or do you have to?
Yeah, so I've got in that telescope, I've got a 7-position, actually an 8-position filter wheel. So this is the filter list that I have, and basically I tell it go to this filter, and the motor will turn and it'll line that filter up in front of the camera sensor.
So as long as you put the right filter in the right position, then it goes, puts that filter in and starts imaging.
Yeah, right. I mean, once I install the filters in this filter wheel, it's a motorized filter wheel, I never open it again. So these filters are there permanently. I know the positions as far as where they are in the filter wheel. So when I tell it to go to a filter, like, I can come down here, set filter position, I can change it to blue, and I hit set, and it says moving, and when the blue filter is locked in, it turns blue. So
what you just did. Okay. No, I think that was neat.
Yeah, so I can just program that sequence in and get the whole run programmed out for the night, and it'll take, I shoot with a mono camera, and that's a whole nother story as to why you would want to do that. But generally gives you a lot more flexibility in your final results, and it also improves the quality of the single captures. So that's why I shoot with a mono filter or mono camera through all these various filters. And
makes sense.
you want to look through these filters for various reasons, but these first three I have listed here, the HA03 and S2, those are narrowband filters, so they allow you to pick up a little bit more detail and contrast in your images because you're blocking out light pollution and other extraneous light. And you can shoot those filters even during, bright moonlight.
Yeah.
Like I was saying, this is shot in HA last night. This is hydrogen within the Rosette Nebula. So this is a shot at 1500 millimeters too. So that's a pretty zoomed in image.
Yeah, it looks good.
Does
Well,
look-
it has the makings of looking really good when you add the other elements, with the other filters in, and then combine them.
Yeah. Given, I'm sorry I had to make a 180 here. I don't have a nice presentation like everybody before me, but I was planning on showing this live imaging and kind of editing the results as they came in. But
I'm pretty sure Scott's got stuff in the comments with a lot of, I know there's some astrophotographers that are in the watching, and
Right.
they're soaking this information up just like I am. So it's worthwhile.
yeah, and so there's a lot of software you can use to do this. I've kind of settled into Sequence Generator Pro, but I'm using an older version because the newer versions you have to pay per release, and so I just kind of it work. If it ain't broke, kind of thing. It works, so I just stuck with it. And it allows the automation, which is all I'm really looking for. So I can set this up, and I generally don't have to go outside again, and I can
just let it go. My automation is EOS Backyard, and I have yet to reintegrate it into a process. And trying to do some of the wide field stuff that I do. I typically set up, point, and shoot. But there are times when I attempted to just take one frame after another and sequence it. So I haven't quite gotten there yet, but I think gradually over the next couple of years, I'll probably start to work with that.
I think the automation software, if you're going to shoot from home, I mean, it's one of those game changer things. I used to go out there and focus the telescope by hand. I'd be laying on the ground trying to look through the camera, back of the camera. Now I've got a motorized focuser. I've got the automation set up. It's just I put it out there, set it up, and it's good to go for the night.
Yep.
All right, so the topic that Scott had laid out here is the Golden Age of Astronomy, and the James Webb Telescope was featured on the image, and I think it just reminds me a little bit of how far we've come as amateur astronomers with the capability and the technology and our ability to see way out into the cosmos. So I had a few images that kind of meant a lot to me when I shot them. The show opened with the Hubbell Deep Field, and those kind of images always spark my curiosity and imagination, and I want to show a couple of those that I've taken over the years. So got a window here with the with Photoshop to show some of these images. So what I'm going to show is a series of galaxy cluster images. What you're looking at here is Abel 1656, which is part of the Coma cluster. And the Coma cluster is a group of galaxies somewhere around 1/3 of a billion light years away. So they're about 300 million light years on average away from us. And the cluster you see on the screen, I mean, to me is a little bit reminiscent of the Hubble Deep Field, where these fuzzy dots aren't stars, they're all images. And as you zoom in, you can start to see more and more of those. This was shot through the 8-inch SCT that I pictured earlier from the backyard.
So we should call this the vast reaches deep field.
Deep field. That's
Yeah,
right.
I've taken a few of these and we'll see some of them, but as you zoom in here, you can realize that these aren't stars necessarily. Most of the dots you see here are actually galaxies, and the Coma cluster is known for one of the densest clusters of galaxies up there. I think there's over 1,000 galaxies identified in the cluster. And it's one of those things of the deeper you look, the more you'll see. Just little faint fuzzies off into the distance. Some of these, the main cluster might be 300 million light years away, but some of those faint dots in the background, probably looking at billions of light years away.
Yeah, I was looking to see if you happen to catch any gravitationally lensed galaxies in this image.
Well, wait,
And
I got something you might be interested in. A couple images, but all right. So the next one I have here is Avo 426, and that's the Perseus cluster. Again, another dense cluster of galaxies. The distance to these, I think, is a little bit closer. Maybe they're 250. Got a reference over here, so I don't remember all this stuff. It's about 250 million light years to the average distance of this galaxy cluster.
Wow.
One of the cool, I don't know how to zoom in that view, sorry.
It's
One of the
almost like
cool
the
things
galaxies
about,
form constellations in themselves,
yeah, I mean, they're like basically constellations of galaxies. Some of these are interesting ellipticals. This one, I forget, I think it's NGC 1275. Yeah, Perseus A.
Yeah.
This one's got a really dense web of hydrogen alpha filaments within it. It's a really interesting one to look up if you ever get a chance to see the Hubbell image of that galaxy. Let's see if I had.
And Jason, that's got a very active supermassive central black hole. So you can actually see in your image here in NGC 1275, which is a CD galaxy, it's a huge elliptical, but you can see the disruption from the black hole in your image here. Look at the envelope of gas. That's pretty incredible to image that, from the backyard, as it were,
Yeah, I wanted to show this. So this is the Hubbell shot of that, which, you put mine alongside Hubbell and you can see why we spent billions of dollars on Hubbell, but, it's there. And when you get outside the Earth's atmosphere with the clarity that Hubbell is able to provide, you can see just how crazy the center of this galaxy is. Filaments of dust, bright blue, regions of star birth, and then you've got these just sprawling filaments of hydrogen.
well, not only Hubble being outside the atmosphere, but then all of the time, it can also integrate from that data.
Yeah,
And
the
the fact
interesting thing
that
is Hubble does, typical Hubble images, they don't integrate for nearly as long as, say, I would, but the reason I do it for so long is to beat the light pollution.
Yeah.
A 90-inch mirror doesn't hurt either,
Right.
Yeah.
I'll get there someday. Yeah.
Yeah, we take baby steps. I mean, you have the basic, just like we talked about it with the crab. The fact that you've got very similar elements in your shot from a backyard is the and even you've got like a faint, there was that galaxy that was near it, I think, and you've got like a faint part of it. It's something that's so faint it barely shows up, but
it's images
there.
like this. I mean, this is again just another reason why we're in the golden age of astronomy. This is not only within the realm of professional researchers. This is something that the amateurs really can do from their backyards, if they apply themselves like Jason has.
Yeah, I mean, I think back even a decade, I wasn't doing this a decade ago, but a decade ago, is about the time I started to get interested in it. And when I started looking it up, you know, what it would cost and the equipment that was available, in contrast to what's available today, I mean, the price of entry is so low. The technology is significantly better. So yeah, I mean, there's no better time to, if you want to get into this and start photographing this stuff from your backyard, there's no better time to do it than now.
Right.
Except maybe 10 years from now when everything's that much cheaper.
Even better.
Yeah, 90-inch mirrors cost a little bit less than 10 years. Who knows?
Yeah, I'll have a space telescope by then.
Yeah.
All right, so next one, another galaxy cluster. This is the Hercules cluster. NGC, or sorry, not NGC, Able 2151. And this is a cluster of about 200 galaxies. Further now, this is about double the distance of the Perseus cluster. So we're looking at smaller and smaller galaxies, but there's you know, some really cool details in these too. You know, you've got less of the yellow elliptical galaxies, and you're starting to see a little bit more of edge-on spirals, which are always interesting. Face-on spirals. And there's even some interacting, or they may or may not be interacting, but they're overlaying spiral galaxies here. And you can see, you know, some galaxies with these are classic kind of tidal tails from interacting galaxies. Again, you know, just another one of those images where the more you look, the more you see. I mean, I'm zooming into the center, but everywhere you zoom in this image, you'll see little, you know, spiral galaxies. All right, so that's the Hercules cluster. Okay, now we're on to Arcturus chain, which is part of the Virgo cluster. Another large cluster of galaxies. This one is a lot bigger in our sky. This is taken with a 400 millimeter telescope. So these objects are significantly larger than, apparently larger than the last one. And off the, I guess off this frame is M87, the
That's beautiful.
galaxy that we have
It's just
a black
beautiful.
hole within. But
Yeah, if the guy's making images with the 100-inch and then the 200-inch could kind of zoom ahead to our time now and see your images made with the 8-inch telescope, I think they would be utterly flabbergasted, you know, at what amateurs are able to produce. And you in particular, Jason.
oh, thanks. I put a lot of time in these images. You know,
This is,
each
I
one
know
of these,
this is
each
really,
one of these is probably, you know, anywhere from 15 to 24 hours, 25 hours of integration in each of these images. So that's a lot of time that telescope's sitting out there just collecting photons. And you know, the reason you do that is so you can average down that light pollution.
Well, I know when Hubbell took its time looking at that real small area in space, I remember the hearing about skepticism, and those of you that are more in the know could correct, but there was skepticism that anything would show up until they actually did it, and then were surprised when they saw all of those galaxies, you know, 10,000 or so in number in that one small area. And I'd be curious to know if they knew it was going to produce something but didn't know the number, or if it was an experiment, we weren't really sure, and then that sort of taught us, you know, gave us more insight into just how many galaxies are out in our universe.
They knew how many would be there, but not that many. So the fact that the ultra deep field has 10,000 galaxies in that tiny piece was a little surprising. And that's how they extrapolate that piece of sky and come up with the 100 billion galaxy figure in the universe. You know, it's just an extrapolation of Hubble data.
Yeah.
Yeah.
Okay.
All right, so one more cluster I have here is Able 2218. And this one is in Draco. And interesting thing about this one is this is a more distant galaxy cluster. It's, I think the main cluster is over 2 billion light years away. So that's the
Wow.
center little cluster down in here. And the reason why this one is notable is Hubble took an image of this and surrounding the large lenticular galaxies down in here are where arcs of gravitational lensing, where the gravity of the net gravity of the galaxy cluster actually bent the light from behind and produced images of galaxies that are behind this, which wouldn't otherwise be visible. I wanted to see if I could capture it from the backyard, and
There it is.
You've got
Well-
the arcs. I see them.
yeah, so these arcs are incredibly faint, but yes, I did get one of them here. Which you can see if you can see my
Yeah.
mouse.
I think you got the other one just up above it and to the right. It's faint, but I think that's another arc.
Yeah, it kind of loops all the way
Yeah.
through here, but you can see now how zoomed in I am on my image here. I've taken a shot with a 1500 millimeter lens, and now I'm zoomed into the pixel level here, and I'm picking out gravitational arcs that are 1 or 2 pixels wide in this image.
That's crazy.
But I can show you here what Hubble did on that same thing. And the rotation is a little bit different. So this arc here, you can see in the Hubble image, lines up with this arc here.
I see. Wow.
So yeah, there's another little arc here, which, you know, you talk about pixel peeping. To pull this out of my image, I have to get down to single pixels. but I did it. I mean, I would
Spectacular,
I
Jason.
would say that's a success.
Yeah,
Yeah.
big time.
I mean, you've got data that you pulled in from those galaxies, those lensed galaxies, into your sensor, and you have an image of it. It's
Yeah, I'm not actually
ahead.
sure with these lensed galaxies if they actually know how far they are away because of how mangled the gravitational lensing makes the spectrum. I don't know if they can get redshift numbers off
I
these or
thought
not.
there were calculations for it, but I'll again defer to, like, if you Eicher or
And they can estimate the distance of the background galaxy. And, you know, Jason, congratulations. You've again independently proven that Einstein was right.
Yeah, I mean, without the Hubble image, I don't know that I would have picked that out as a galaxy, but or a lensed galaxy anyway.
Yeah, I know it's hard sometimes to tell what's an artifact, if an artifact versus actual data, but being able to compare to the Hubble data, it's not just a pretty picture. I know some astrophotography, especially of well-known targets, becomes an exercise in how pretty can I make the picture. But I think we can see with your images, Jason, just how much more involved we can be as amateur astrophotographers and citizen science by getting as much detail as we can and actually reproducing some of these fields. Something, I guess, 10 years ago, probably not, can't do that. That's, too much. But with something like that on your screen, you're able to see a gravitationally lensed galaxy. And, I think that's the gravity, pun intended, of how that, how you've proven we can do that in an amateur level. That's definitely something to be considered. I've basically run out of words.
Yeah.
So
Right.
yeah, that it is amazing.
Yeah. These kind of images take your breath away. Absolutely.
Yeah, I've got, here's another example. So I went on this adventure where I was trying to compare what I could get from the backyard to what Hubbell gets. So here's another look, Adrian, if you're curious, and how an 8-inch backyard telescope compares to Hubbell. But this is little galaxy pairing, ARC 147, a couple of ring galaxies. Very distant, let's see, 440 million light years away. But that image on the right is obviously the one Hubbell got of this pair, and that's on the left is mine.
That is so beautiful. That's amazing too.
I think you got, I mean, you got all of the
That's great.
detail, and you know, your finish. It's just looks like a miniature, the one that Hubbell, and
Yeah,
you
it
can even
does.
see the little gap in the bottom of that ring galaxy that's on
Yeah.
the bottom in your image. So it's a splendid job.
Thank you.
It is.
But that's all I really had today. I probably went long, but it was just more of a show and tell.
Well, we thank you very much, Jason, for coming on to Global Star Party again. And
Yeah, are there any
I look forward
questions
to
on any
seeing.
of this stuff, or I didn't look at?
What's that?
I didn't look for any
Let's
questions or
look
anything.
here. Let's look here. I'll read some of the comments here. Mark Helton saying, Jason is someone whose astrophotography I strive to be like. Practice, practice, practice. This stuff is amazing. Harold Locke says, nice composition. Norm says he's got a great eye for the color. Fantastic image of Markarian's change from Beatrice. Let's see. You're just blowing people away. I mean, you know, many accolades here. César Brollo says the details from Jason are incredible. You know, and after a while, there are not words. And, you know, as Adrian pointed out, so it's the images speak for themselves, and it's just incredible what you're presenting here tonight. So thank you for doing that. I think it makes
No problem.
this
like to
whole
share
theme
it, you know,
of
some of
the
these-
golden age of astronomy all the more poignant. So thank you very much.
Yeah, you're welcome. Thanks for having me.
Yep. All right.
Yeah, if you want to find more, you can find my stuff on, you know, I just usually have the username, the vast reaches at any of these social platforms. So you can find my stuff there.
Yeah, I'll post it in chat there.
All right, thanks.
And Jason, we are still gonna be on. I gotta call you up when we go. We get a clear night one of these nights to head up and try and capture something. I've been meaning to send you a text. I know it was cloudy the last time I tried, so we'll.
Probably a lot these days.
Yeah, it's dead of winter. When it's clear, it's negative 20 Celsius. So if we have to kind of pick and choose what we're going to do, we either bundle up, or of course you have the option of being inside. You don't have to be out there too long. Me, I go on location near the lake, so I got to bundle up. So.
Okay. All right. Well, let's, our next speaker is Caitlin Ahrens. She is a postdoc fellow at the Goddard Space Flight Center. She's involved with several planetary missions that are currently underway, and she loves Pluto. She is an expert on ices in the solar system, and she has a sparkly personality that just makes anything she's talking about so interesting. And I love having her on our programs. She did a stretch called 7 Months of Science, where she brought on scientists from all over the country, and it was it was quite a ride. And those programs are still out there that you can watch. And I think they'll be watched for quite a few years. Caitlin, how are you today?
I'm doing fantastic and chaotic. How are you doing?
I'm with you. So maybe more chaotic than fantastic. I don't know. But I'm very, very happy to be here tonight, celebrating our 80th Global Star Party. And I'm really honored that you decided to come on with us. So thank you, Caitlin.
I'm so excited. Oh my goodness. So today is particularly chaotic for us planetary scientists folks, because today was the paperwork, the abstracts are due for our big major planetary conference that happens every mid-March. It's called the Lunar and Planetary Science Conference. It's been going on since the mid-1960s. So this is our biggest planetary science conference in the US. And so the paperwork was due today. So a lot of just mountains of emails and people trying to race for that 5 o'clock deadline today. Yeah. And everybody's now kind of in like, whew, awesome, great. And everyone will panic again in March when everybody realizes, oh, gee, I'm going to have to do the work that I just wrote down I would do. So that's 2 months away from now. We got the paperwork in, everything's fine.
Good.
So I kind of want to give a quick little call back to David Eicher's talk about minerals of Earth. There was a particular mineral that he showed where it was copper and kaolinite. And as the quote was, kaolinite was not a very it's a very common mineral. It's just kind of like it's kind of dull. It's kind of boring. What's interesting though is that kaolinite is actually found all over Mars, and it's really entertaining to have minerals that we would have so much commonplace here on Earth, but to find the similar minerals on Mars and the moon sometimes, and asteroids and so on. And to have that kind of comparison. So it's really interesting to bring about something that you would learn in Geology 101, what's quartz, what's basalt, what's this rock and that rock and so on. But to put it in the context, kaolinite, which is it's just a boring white, powdery, almost talc-like mineral here on Earth. Yeah, it's just as boring as it is on Mars, but to find it on Mars and to find it on certain parts of Mars is very exciting, because for it to even exist on Mars, there would have had to have been some sort of water interaction to make kaolinite and to create certain kind of clay minerals on Mars. Now, as far as Golden Age of Astronomy, here's like the Golden Age of planetary science too. Again, with the minerals, now we're realizing that there's minerals on Mars that have never been discovered before. And that there might even be a third newly discovered mineral. So press release maybe soonish, but anyway, so at least within the past 7 years, we have discovered 2 new minerals on Mars, which are very exciting. The rovers have discovered it, and we are starting to see them in meteorites as well, but it only pertains to Mars. And what this tells us is that there's certain temperatures and pressures on Mars that maybe we just do not understand. So we're still trying to figure out, how do we even recreate these kind of mineral structures for ourselves, if at all. But so far we haven't been able to. It's been about 7 to 8 years worth now, so still working at it. But that's the fun part about rocks and minerals on Mars. So let's get to the golden age of planetary science. We're going to be busy. We're going to be absolutely busy. Now, most of the media has been all about Mars this, Mars that, good job, Perseverance, good job for like the Hope probe and United Arab Emirates. It's going to be fantastic. 2022 this year, Happy New Year, everybody, is going to be busy because 2022 is essentially the starting point for a lot of other missions too. So I actually just got the final number earlier today. I was trying to figure out how many missions globally, internationally, partners here, how many are launching just this year. Now, usually in the news, you typically hear of, Perseverance, James Webb Telescope, OSIRIS-REx, maybe a couple per year. 2022 is going to be very, very busy. I have counted 10 different global missions just this year that are going to launch to their respective places. And that's just 2022. There are dozens more from 2023 all the way up until 2030. And we're constantly, consistently as well, pushing for more smaller missions. NASA back in 2018 just released their newest initiative for planetary missions called the CLPS initiative. So CLPS, CLPS, is an acronym for Commercial Lunar Payload Services. So NASA would actually provide the lander, almost like the chassis, if you will, and the rocket. But what they said is that they bring about proposals, whether you're at a university institute or some sort of planetary institute, so on and so forth, or a government agency, to create the payloads to be put on the rocket or the lander or the rover and so on. So now we're getting more into commercialized private space industries or commercial space industries to bring about those payloads. And then we can do more science, which is going to be absolutely fantastic. But at the same time, absolutely busy as well. So CLPS missions are apparently became way more popular than NASA had thought. So we're going to actually be starting some of those CLPS missions starting this year. So without further ado, here's the lineup for 2022. Starting off with Artemis 1 launching in March 2022. So that is only a couple months away. So keep in mind, though, Artemis 1 is just the dress rehearsal for Artemis 2 and 3, which will be crewed missions. Artemis 1 will be uncrewed, but it's just to make sure that we can actually get to the moon and back. Next up on the list is the JUICE mission. So JUICE is the Jupiter Icy Satellites Explorer. So the European Space Agency is now going to send their own version of the Juno space cam out of NASA and JPL that's currently going around Jupiter. If you were to Google Juno Jupiter images, you can have all sorts of gorgeous, gorgeous images and fun with like the polar regions of Jupiter. It is gorgeous. Next up is Luna 25. This is out of the Roscosmos mission initiative. Next up then is the Korea Pathfinder Lunar Orbiter. So South Korea is now on board to go to the moon very soon. Then we have Psyche. The Psyche mission is to launch in August 2022. So Psyche is, lo and behold, going to the asteroid Psyche. But why? Is because Psyche is a very heavy, dense, metallic asteroid. We really want to know what makes it so heavy and metallic. So that's going to be exciting for Psyche. Then we have the ExoMars / Rosalind Franklin rover as well. So that's ESA and Roscosmos collaboration there. So that's supposed to be September 2022. The Hakudo R1 out of Japan will be in October 2022. Then we have the Emirates lunar mission, supposedly in later October 2022. And then we have two CLPS missions at the ready. One is called Prime 1 and the other one is called Mission 1 out of Maston. So those will be supposedly around December 2022, pending no delays. So 2022 is going to be a very busy year for a lot of launches. Most of these to the moon, whether they are orbiters, actually, yeah, most of these are orbiters or just very simple landers. Most of these are test runs, if anything else. But those test runs can really prove useful because then we have a little bit larger lunar missions coming up. So the moon is going to get very popular very soon. So besides Artemis, so not including Artemis, there are actually 21 lunar missions already scheduled all the way up until 2025. And there's more. There's more counting. So I lost after 21 and I was like, nope, I'm not going to count it anymore after that. So it's going to be very busy. And that's just the moon too.
Yeah.
There's a couple others.
It sounds like humanity heeded the call to go back to the moon and the whole globe responded.
Absolutely. Yeah. Absolutely. Because why not? Why not?
No one wants to miss out on this one. So that's cool.
Yeah. And you wouldn't happen to know where I could get a ticket to be on any of these rockets, do you?
Oh, goodness. Well, have you tried it?
No, I'm going to assume probably not, at least not yet. I don't know. Do you envision somewhere in our lifetime, maybe yours more than mine, because I'm 50, do you imagine that moon trips might become a thing?
Yes. I hesitate with that. Because I have my pros and cons about space tourism. So I think it would be an interesting idea. But I think a lot of science, a lot of educational resources should be utilized more with those particular launches. So less on the tourism, let's take a selfie with the moon, and more toward, how cool would it be to start sending payloads from a 5th grade classroom up and around the moon, and to do that all over the world, to bring about more of an educational resource side to these payloads, I think would be
a much better use of those resources. I would agree.
And hanging out at a nightclub on the moon, so
yeah,
it might be fun, but I don't know.
But I'm thinking 2030 we do a lunar star party. What do you think? Ourselves up
with
there.
That's only 10 years from, let's see, 22, 8 years from now, Karim. So I could possibly make that in good health.
There you go.
I'll have to figure out how to make an eyepiece that can get through the glass of your helmet. So I don't know.
And I'll be sure to bring my little Explorer Scientific mount.
Hey Scott,
So
you could always use your 3-inch eyepieces.
Yeah, I do have a 3-inch eyepiece. That's true. I'll have to make an even bigger one. Caitlin, Michael Carroll, who's behind the curtain here, had a question. He says, what is the Japanese mission going to study?
Good question. So Hakata R1 is going to just be a simple orbiter. So the Japanese Space Agency has been more focused on Venus as of late and Mercury. So I think them going back to the moon, this is going to be kind of their version of CLIPS. Hakata R1 is going to be also commercial payload as well. It's not part of JAXA.
Okay. All right. Thank you. Caitlin, thank you so much for coming back on. We are going to take a 10-minute break. And is there any last words of wisdom from Dr. Ahrens and Goddard Space Flight Center?
Pluto is a planet, everybody.
Pluto's a planet.
That sounds like wisdom to me. And I know they are all called worlds, no matter what they're classified as, but I also know there was plenty of evidence with geological things going on, things that planets do. So, all of these arguments are sound in my book.
Absolutely. And real quick then, since we're plugging books and whatnot, I just recently contributed some chapters to the recent Mars volcanic book, Mars, a Volcanic World by Springer.
Oh, wow. So it's a Springer book. Great.
Book, yeah. So
wonderful.
Read for those who want to learn all about volcanism on Mars and how weird it is.
Cool.
Awesome. Awesome.
Excellent
right.
presentation.
Absolutely. Absolutely. So now we'll take a 10-minute break. Stretch your legs, get a sandwich, get a hot coffee, and we'll see you back in a few minutes.
We got a break? I just got here.
Well, for the rest of us, it's really cold, so we need some tea or coffee.
I just came down from a place called Mount Pinos, delivering something, which Scott kind of ran away, but the guy that I was dropping off a telescope to happened to have one of Scott's mounts that they don't use anymore, which is kind of amusing. I see Jason. The hell?
Did you get to see Jason's presentation? It was incredible.
I literally just got home, so I didn't know what time he was up, but I could see him.
You'll have to rewind a bit to watch later. He caught some Einstein rings from his backyard. It's amazing.
Oh, nice. I feel like I miss everything all the time now.
That's the nice thing about the way it's live streamed is you can go back to it. I've missed a few weeks, and whenever I go back to it, I get to just sit and watch while I'm having dinner or while I'm working on some prep for my classes, and it's nice to have that in the background.
Yeah, for sure. I think that's what Scott was saying about the Star Party, or doing it in this format, is we can actually be sitting doing whatever it is that we're doing and feel like we're still part of something, if that makes sense.
Yeah. I mean, when I hear Adrian talk about his outings, or when Maxi or César are sharing, I actually feel like I'm out there with them.
I know, it's a weird way of doing stuff, that's for sure. I mean, to be totally honest, I kind of had the feeling that this was where everything was going to be going at some point in time, where, we can be together but still be like hundreds of thousands of miles apart.
Yeah.
I'm looking forward to the day where I'm just sitting there talking to some random person on the moon doing, imaging or something like that.
That's what we were saying. 2030. We gotta get somebody up there to connect in from the lunar surface.
What would I'm just curious. What would the delay be?
Well, if it's good, it'll be just a second and a half. But it depends on exactly how. It depends on the pickup speeds between the satellites that bring it back and forth.
Well, I mean, if it's going to be long-range radio, let's have a look. Radio waves propagate in a vacuum at the speed of light.
Yep.
So basically, the delay is 2.4. Well, we'll say 3 seconds, give or take.
But you have the transfer time, and the transfer time is the lag, right? It's the actual processing at every point where it's transferred from one spot to another.
Mm-hmm.
Which is why you have a lag now as well, right? So,
right, but the lag that we have is almost barely noticeable. I mean, we're talking the maximum it could ever be is what, 300 milliseconds? I wouldn't even notice that.
It's enough time to catch your foot in your mouth.
Possibly.
And just like that, Adrian is back. Hey, Adrian.
Oh yeah, there he is. Quick, be quiet. Everyone mute. Click.
Whatever I said, I didn't mean it. Okay. No, I decided I'd try. I've been doing black and white landscape astrophotography or nightscapes, just trying it out lately. And it's an intriguing direction to go because you don't have the pretty colors that you associate with, like Navin, your background with that galaxy, and you've got some color. When you don't have that color, can you create an impressive image using the night sky, but without the colors in the night sky? And that's something I'm experimenting with. And this image back here with the shades and the clouds kind of covering the Milky Way and the landscape behind it, I'm blocking most of it and probably will continue to do so. But I find it an interesting challenge, and it's something that when I capture my usual landscape or nightscapes, I'm trying out a couple of them in black and white just to see what happens. So that's it's an interesting idea. I don't know how far it'll go, but I had a comment when I posted in my Facebook page. It still presents more of an experience that you would see with the human eyes, a little more so than the, this person was of the opinion that a lot of the astrophotography was over processed and it gets to be a bit cartoonish as opposed to, detailed and looking like something that you would see with the human eye. So I find it interesting and just something I'm trying out.
I'm curious too. I might want to see how that goes.
Yeah, we'll see. I have a couple, my presentation is down a little ways, but I do have some other black and white images besides this one that I wanted to share, as well as some of the first images that I've gotten using an Explorer Scientific mount. It's doing very, very well.
Now, how cold has it gotten out there with the ES mount? Because Mark is mentioning it's 5 degrees Fahrenheit for him. We've got minus 25, minus 35 with wind chill out here in Celsius. So
it worked fine at 6.
At 6 Fahrenheit. Okay.
Yeah, that was some of the pictures I'll show from one of my favorite places to image. It was the mount of choice, and it imaged at 6 Fahrenheit, which I think I forget what it is in Celsius, but it's like 17 or -18. It's doing just fine in
Good.
those conditions. It's
Do you have a heater core connected to it, or?
No, I don't. Now, of course, I'm not staying out there much longer than an hour because the human body can only take so much punishment. The mount is working just as well as I am. So when my fingers begin to freeze, I figure it's probably time for all of us to go back in the truck. But I managed to get a few images and carry the mount. Now, maybe I'm a big guy, maybe so, but I can pick up the mount with one hand, the power source I use for it in the other hand, and trudge off to a different location, roughly polar align it, just look for the North Star, and where I go, the North Star is usually, it's a little harder to see, but you can find the entire Little Dipper. Aim it towards the North Star, take a test image, and if in 30 seconds with a 35mm lens, I don't get any star trails, I know that I'm pretty well polar aligned, enough for what it is I'm doing. So,
well, Norm is saying that he has trouble with the filter wheel electronics because he has a filter wheel he uses directly. You don't do that, right?
Right. No, I'm not typically using filter wheel. I'm using what would be basically one-shot color. I have a camera on top of my mount, and I'm using a camera lens.
Right.
In fact, it's not gonna. This was the camera connected directly to the mount. There was not through a telescope or anything. It was
because you're doing your wide field work, which is great for this weather. But telescope and electronics, it's definitely, that's why I was wondering about the mount, because I have trouble with the mount in this weather, especially when there's any humidity in the air at this temperature. It really starts to grind. It starts to sound. It starts to sound like my 2009 Santa Fe, right?
Okay.
you feel like the whole thing's about to shake and fall apart.
Yeah. Well, I see we have product specialist Jerry Hubbell. I tried to send you a glowing review that the mount was holding up very well to my crazy intentions, setting the thing in the snow and going for it.
Yeah. So we do have quite a few customers up in Canada that have used the mounts, the Exos 2, the Exos 100, Exos 100 mounts, and very cold, down to I think down to 20 below actually.
20 below Fahrenheit or
Fahrenheit.
Okay,
Fahrenheit,
yeah.
Which is pretty darn cold. I mean, I don't know how much you want to, but And then long-term stability or reliability is something else that we've really pushed for in our design. And we've had the PMC8 system in our observatory here, and we get temperatures down to 5, 10 degrees up to 100 degrees. So they operate, well, at least the G11 PMC8 box operates fine in a wide range of temperatures.
Yeah. Well, we'll carry on more after maybe during my segment.
Well, we're back. This is near now into the second session of the 80th Global Star Party. We've had some great speakers so far, and finishing up with Dr. Caitlin Ahrens from the Goddard Space Flight Center. Our next speaker is from John Abbott College and the Royal Astronomical Society of Canada, the Montreal Center. And Professor Karim Jaffer will be on with us to cover aspects of the reason why we are now in the Golden Age of Astronomy. Karim?
Thanks, Scott. Hi, everyone. It's great to be back. I unfortunately missed last week's Cosmic Dust Global Star Party, and thankfully, the person who I was going to host, Quatran, joined, and he was able to provide an amazing talk on some of the inspiration that he had growing up. And that kind of got me thinking in terms of that side view of what we thought about astronomy and space science when we were growing up. So I'm going to chat about the Golden Age of Astronomy in a bit, but I'm going to do it from a slightly different perspective. But before I do, I just want to do a quick touch-in with a check-in with the RASC Montreal Center and tell you a little bit about a few of the things going on. First off, tomorrow we actually have our Citizen Science Series episode 2. And the reason I wanted to share this with you right away is because Dr. Ahrens talked about the Juno image processing, and that's going to be my segment in the Citizen Science presentation, where I'm going to walk through a very simple way to get some of the Juno images from the actual Jupiter Juno site. And what's amazing is even with free software like GIMP, you can walk through and process it really nicely and get some of the details out of the Great Red Spot, of the colors of some of the clouds and some of the textures that you can see. And you can even track storms over passes that Juno has made across Jupiter. We also are going to have a small talk on quantum entanglement and a little bit on Russell's first adventures in radio astronomy. You can visit our website to get more information, rascmontreal.org/Titan. And the link is in our calendar, so you can join us tomorrow at 8 p.m. Eastern Time, which is 7 p.m. Central. And by all means, guests, especially our Global Star Party audience, you're welcome to join us at the RASC Montreal Center. I also wanted to tell you about our next public event, which we are doing with Guelph Physics. And Guelph is my alma mater, and it's actually Dr. Roberta Bondar's alma mater as well. And we're going to be celebrating the 30th anniversary of Dr. Bondar becoming not just the first Canadian woman in space, but actually the first neurologist in space. One of my former students, Virginia, she's an astrophysics student at the moment at Bishop's University, and she's going to be giving us a little bit of an overview of Dr. Bondar's journey and her work aboard the Discovery, but also afterwards what she did to help study astronauts' exposure to space. And she's continued work for almost 3 decades now on the impact on the brain of strange environments for humans. She's also a photographer by nature. So she's one of the only astronauts to be an actual artistic photographer and take surveys of all different areas of the Earth, which is incredible. And then our past president, Catherine Dulong, is going to present some work that she's been doing with the Canadian Space Agency for the last year on feeding future astronauts. So when Scott put up his theme for this week on the Golden Age of Astronomy, I immediately thought citizen science, because that's kind of one of the things that I love about the Golden Age. But I knew that there would be some talk on citizen science with what Dr. Ahrens said. And I thought about talking a little bit about space shuttles and space exploration, and Libby did an amazing job of that. But then it occurred to me that Dr. Bondar's anniversary gives us a different vantage point to examine what the Golden Age of Astronomy means, especially for kids growing up right now and over the past years. So I want to talk to you briefly about one of my former students at John Abbott College, Catherine Dulong, who's going to be part of this event on Saturday, January 22nd, which is going to be available live stream on our YouTube channel. So Catherine was a student at John Abbott, but not in my astronomy class. She was actually one of my core physics class students. But even though she wasn't in the astronomy class, she was incredibly active in our space club. She was one of the students who helped to organize our partial eclipse event, where we had 5,000 people come on to the field at John Abbott College on the first day of class in 2017 to see the partial solar eclipse. She stayed active and helped out at all of our events, even when she became an alumni. And during this time, one of the things that I love is that she would talk to other students, not about the science of astronomy or the science of astrophysics, because she didn't have an interest in that. She would say, I will never formally study physics. She had no interest in it, but she loved astronomy. She loved the way her heartbeat changed. She loved her pupils expanding as she got used to the night sky and how that actually connected with her. But her passion was in a different area. It was in food sciences. It was in nutrition. And she's found a way to take that passion, her career in nutrition, and apply that to space sciences and work with the Canadian Space Agency for over a year now on projects for how we will actually support astronauts, not just going to the moon, but also moving past that to Mars and exploring the rest of the solar system. And it started me thinking about the way in which we started looking at space as kids. So when I was growing up, and I don't know about many of you, but a lot of us grew up in around the same era where, you know, we saw the first steps on the moon, or we saw the shuttles going up, and we saw astronauts taking those steps into space exploration. And so when people would say, you know, you love astronomy, you love the solar system, you love the planets, what are you going to be when you grow up? A lot of us thought our choice was astronaut. Or if you were really feeling like, you know, you really love the science behind it, you could, you know, there was always the joke, you could be a rocket scientist, or not everyone is a rocket scientist. And you could sit there and work on chalkboards, and you sit there and do all of your calculations and everything. But if you really love the actual objects in deep space, if you love planetary science, if you love examining it, then you could aim to be an astronaut like in the days of old, or you could aim to be an astrophysicist and work through the mysteries of the universe. Or you could aim to be both, like Jocelyn Bell Burnell, and actually work as an active astronomer, but identify what it is you're observing and discover new and amazing objects like pulsars. So when you were growing up, everything you thought of was kind of hedged into these certain little windows of what you thought space meant, what you thought astronomy meant. And then last week, watching this cosmic dust GSP, one of the things that stood out to me was this slide that Dr. Ahrens presented about studying dust bunnies. And she talked about how incredibly interdisciplinary it is. The idea that you don't just have astrophysics, you also have heliophysics, you also have astrobiology, you have climatology, you have geology, chemistry, engineering, and you bring all of these fields together. And that's really the way in which science works now. And when you start looking at some of the exploration that we're doing in the solar system, you look at the rovers and you look at all the different fields that are combined together, you recognize that if you have an interest in an area connected with space science, you have the opportunity to be part of the golden age of astronomy and move it forward. And even if you've done your education a long time ago, but you have an interest in these areas, citizen science is there to help you to actually participate in the scientific work being done by the rovers, by the probes in the solar system, by the remote telescopes that we have access to and the data that comes out of them. like what Jason was saying earlier, I mean, we have this data that comes to us that we can actually work with and learn what it means and interpret it. And Michael was saying that, we can even interpret it artistically at times. When I talk to my students about a lot of this, one of the things that comes up is when we build some of these different solar probes or Earth observation satellites or rovers, we're building not just, the Canadian Space Agency, everything's done in their little compound in the South Shore off of Montreal area. It's actually done at companies throughout Canada, and they all have different contributions to building this amazing satellite system that's examining the environment of Canada 24/7. And so when RadarSat Constellation came out, the CSA put out this amazing infographic that showed all the different companies that had contributed to the building of RadarSat. And when I sat on the side of the highway watching these constellation satellites being put onto these transport trucks and driven to Ottawa to be tested at the testing facility there, and then shipped down to California to be launched, it occurred to me that we also have to recognize that launch is done by SpaceX with the Falcon 9 rockets, which are these reusable rockets that came from this vision that allowed us to start to explore space in a more reusable, more sustainable fashion. And one of the things I try to get across to my students is this means that no matter what area you go into for your career, no matter where your attitudes, your skills, your passion lies, if you're interested in space, you can remain connected to space. So I take them to the Canadian Space Agency website, and I talk to them a little bit about the different careers that are focused at the CSA. And, they talk about engineers, they talk about technicians, they talk about health science experts, which now is a burgeoning field for really helping with space exploration and the idea of manned spaceflight. The astronauts themselves is a very small avenue, but it's still something that I want my students who are interested, who are passionate, to feel that they can aim towards. And then there's the scientists, the astronomers, the astrophysicists, and they have an amazing role in really setting up where our exploration will go and what our exploration means. But that's not where it ends, because we also have the consultancy and general services. We have financial services, without which none of these programs, none of these companies, none of these institutions can hold. You have IT services and intellectual property management. And then you have publishing and graphic arts. And publishing and graphic arts meant the world to us as kids, because we didn't have pictures of Jupiter. We had artists' rendering of what Jupiter would look like. We didn't have pictures of what the sun's surface looked like. We had artists rendering based on the data that we had taken and what we understood from those grainy pictures that we took back in the 60s, 70s, and 80s. You have multimedia products and services, you have marketing, you have communications, you have all of these different areas that are still integral to the golden age of astronomy. And then above and beyond all of that, you have how we interpret and teach this to the next level, which is journalism, like with Astronomy Magazine, Sky News Magazine, Sky and Telescope, etc. You have education, all the schools and all the programs out there, not just the actual programs within schools, but also educational outreach, such as what we're doing here at the GSPs. And then you have visual arts, a way to actually connect to the information that you're learning in astronomy and in this golden age that we have. So what I wanted to bring to the table today was this idea that the golden age of astronomy doesn't just mean that there's a lot more astronomy there and a lot more tools that we can use to study the space and the universe around us. It also means there's a lot more avenues for us to be part of that journey, to be part of that search and part of that golden age. So with that, on behalf of the RASC Montreal Center, thanks for your attention. And again, you're welcome to join us tomorrow at our Citizen Science Talk or next week at our Dr. Bondar's 30th anniversary celebration.
That's great. Thank you so much, Karim. Again, if I ever had a teacher in astronomy, a professor of astronomy, I would want it to be you. I mean, you are so engaging and so inspiring. I think it's infectious. I think everybody gets that. So, and we all
thanks
love
so
it.
much, Scott.
Thank
we all
you.
wanna
Yeah.
we all
You'll
wanna
have
be
to-
in your class, Karim.
But this is my other classroom. I've told my students, I said Tuesday night, no office hours. I'm on the GSP.
Amazing.
Excellent.
Thank you so
Yeah,
much.
see, I finally made my first Sarnia RASC meeting, and it
Oh,
was a blast.
fantastic.
And now I have to try and sneak into the Montreal meeting.
Anytime. And don't forget, you and I have to write an article for Lowbrows at some point.
Yeah, we'll get together and do that.
Okay. All right. So up next is young Navin, who has been on now, I think, Navin, is it 3 global star parties at this point?
Yep, it's 3.
Okay. All right. So what is your big passion? What really intrigues you about space exploration and astronomy?
I feel like I just wanted to learn more about space, and I got interested in space at a young age. And ever since I've wanted to work at NASA when I grew up, and I still have that dream.
Well, I think that you're going to achieve that dream, no problem. I'm always impressed when someone that comes on to Global Star Party who's young, because it shows that you have the interest and confidence to come on to our program. And I think it's wonderful that you're here with some great astronomers, as they are, but they love it too. They love to see young people coming in and giving it their all. So, Navin, I'm going to turn it over to you. What's going to be your presentation tonight?
Today I'm going to talk about microwave radiation.
Okay.
Just give me a second. I'm going to share my screen.
Okay. Nice background, by the way.
Do you see it?
Yeah.
We don't see your presentation, but we see your background.
We see your background.
We see your background.
We see your background.
1 second.
We see your background.
We don't see it. We don't see it. 1 second.
We see your background.
We don't see it. We don't see it. 1 second.
We see your background.
Yep, there it is. There it is.
Here we go.
Here.
There we go.
All right.
Yeah, I think it's interesting. Behind every child that is interested in space, you see the father there helping out. I think that's very, very important.
Or the mother. Yeah.
Yeah.
Or the mother. Yeah. Parents are so key in fostering space, the love of space and space exploration.
Yes.
Otherwise, you become a late bloomer like me. Carry on, Navin.
All right. So today I'm going to be talking about microwave radiation. So what's microwave radiation? It's basically the cosmic it's also known as the cosmic microwave background. It's basically thought to be leftover radiation from the first how our universe originated, from the Big Bang. It's basically heat left over from it, and it's also the oldest type of electromagnetic radiation. So when the universe was young, before the formation of stars and planets, it was much denser, hotter, and filled with a thick fog and hydrogen plasma. And as it goes, and when the universe was born, it also went through a rapid inflation, and it got bigger, and still is today. And as it expanded, the hydrogen plasma grew cooler, and the radiation filling it expanded into longer wavelengths. And you can see in this image, like The size of the wavelengths were about the size of a baseball. And then now let's talk about the origins. It started 13.8 billion years ago. The CMB dates back about 400,000 years after the Big Bang. The temperature was extreme. It was 273 million degrees above absolute zero. So when the temperature had dropped enough, the protons and electrons, they combined to form a neutral hydrogen atoms. Now the newly conceived atoms, they couldn't scatter their thermal radiation by Thomson scattering. So the universe then became transparent. And then in American cosmologist Ralph Afer, I think that's how you pronounce it, first predicted the CMB in 1948, and then in 1965 by American radio astronomers Arno Penzias and Robert Wilson. Then they also figured it out in 1965. And later on in 1978, they'd get a Nobel Prize for physics. This image shows like the genetics when the Big Bang, when the universe was first formed. And this is kind of like, this image here was kind of like a simulation of the Big Bang. Now let's talk about the importance of the precise movement. Precise movements of the CMB are critical to the scientific field of cosmology. Since of any proposed model of the universe has to explain radiation, the CMB has a thermal black body spectrum at a temperature of 2.725 0.0057 Kelvin. And in particular, the spectral radiance at different angles at observation, the sky also contains small anisotrophies or irregularities, which vary of the size of the region examined. They have also been measured in detail and match what would be expected of small thermal variations generated by quantum fluctuations of matter in a very tiny space. Compare expanded to the size of the observable universe we see today. This image right here is the model of the quantum fluctuations theory. And this is also the same thing, but like in a different form. And then now let's go into detail. Scientists have also followed up those results by studying the very early inflation and expanding stages of the universe in 1 trillion seconds after formation. So by giving more precise parameters and atom density, they can measure the universe's lumpiness and the properties of the universe shortly after it was formed. So they also saw a strange asymmetry in the average temperatures, both in the hemisphere and a cold spot that was bigger than expected. And now there are rumors that this cold spot could lead to a parallel galaxy. You can see this is on the model, on the image on the left, this is the universe. And you see this tiny blue spot right here where my cursor is pointing. That's where scientists spotted the blue, like the cold spot. And this is a replica of how it might look like. We don't exactly know because none of our visual instruments can image something like this. Now let's talk about the relationship to the Big Bang. Now the microwave background radiation and cosmological redshift distance relation are together regarded the best available evidence for the Big Bang theory. So now measurements of the CMB have made the inflammatory Big Bang theory a standard cosmological model. Now the discovery of this in the mid-1960s made certain interest in alternatives such as the steady state theory. And this is another image of the Big Bang. Same for this one. Now let's talk about some satellites that help find microwave radiation. The first successful space-based sky map came from the Cosmic Background Explorer. It's this one. It's this one right here. It launched in 1989 and ceased scientific operations in 1993. It created the baby picture of the universe, as NASA calls it. A more detailed map came in 2003, courtesy of the Wilkinson Microwave Anisotropy Probe (WMAP). It was launched in June 2001 and stopped collecting science data in 2010. And the first picture pegged the universe's age at 13.7 billion years old. Now, in 2013, data from the ESA's Planck Space Telescope, which is right here, was released, showing that the highest precision and accurate picture of the CMB yet. Now, scientists uncovered another mystery with this formation. Now, fluctuations in the CMB at large angular scales did not match predictions. Now, Planck has confirmed what WMAP saw in terms of the unsymmetry and the cold spot. So now Planck was more accurate than all the others. And this is the Wilkinson microwave. It's the WMAP satellite. All right, other research efforts. So one is determining types of polarization. They're all based in Antarctica. It's discovered by the Antarctica Brace Degree Angular Scale Interferometer in 2002, and in B modes. B modes can be produced from gravitational lensing of an E mode. This lensing was first seen by the South Pole Telescope in 2013. Gravitational waves, which were first observed using the Advanced Laser Interferometer Gravitational Wave Observatory, or LIGO for short. And in 2014, the Antarctic-based BISAT-2 instrument was said to have found gravitational wave B modes. All right. So, the first one, this is the South Pole Telescope. And then this is, I think this is LIGO. And then this is the Advanced Laser Interferometer. Now conclusion, the microwave radiation still continues and scientists around the world are still fine about our growing universe. And we still have observatories and the satellites at this moment and at this second are still researching in space about microwave radiation. All right, thank you. That's all.
Wow. That was a complex but very interesting presentation, Navin, and I'm impressed that you picked this subject. So it's nice because of all the interconnected support of features seen in the cosmic cosmic background and the kind of the confirmation of things like the universe's age. This cold spot in particular, I think, is really tantalizing. And, so we'll only learn more in the decades to come. But, I'd like to know what is discovered by the time you reach my age, so I think if you stay the course and keep on studying these aspects of cosmology and observation, I think you're going to go very, very far. So
I was also extremely fascinated and amazed by everything I also researched. I never knew some stuff that I researched.
Right. Yeah, that's incredible. Tell us a little bit more. You are 12 years old at this time. Is that right?
12.
Mm-hmm.
I live in Washington, D.C. in Virginia suburb, and then I love astronomy, and I'm an astrophotographer, and I'm a member at the Northern Virginia Astronomy Club.
Oh, so that's near me. Maybe we can meet someday.
Maybe, hopefully.
That'd be good.
Well, great. Great. All right. So thanks again, Navin. And we welcome you to the next Global Star Party, or anytime that you can come on. You're always welcome.
Thanks for having me, and I'd love to come on next time.
Okay. All right. You can count on it. All right. So up next is Jerry Hubbell. Jerry is Vice President of Engineering for Explore Scientific. He is a fascinating guy to talk to. Jerry and I always get involved in these deep conversations on a wide variety of topics, but including technology and astronomy. He is one of the people that has put together MSRO science and works almost every day with the Mark Slade Remote Observatory. So we're going to turn it over to you, Jerry. Did it cloud over at this time?
The sky is not good, like Jason said. It's terrible, actually. It's really one of the worst. You can't focus on anything, and I've got the transparency is poor here, so it looks the sky is real bright with the moon. The moon is basically 10 days old now. I think it is 60% waxing. So it's just a bright sky that's hard to focus. So you can't really see anything. I took a lot of images trying to look at different positions in the sky because we don't have a full sky at the MSRO. We just have a 3/4, or not even 3/4, probably about 2/3 of the view of the full sky, and it doesn't look good. So I wasn't going to share that. But what I am going to share, I think, is some examples, and I wanted to talk a little about first. I think the key to the golden age of astronomy now is really, to me, it's technology. Without the technology that we have that's been built over the last 20 years, especially for amateurs, but actually since the Apollo program really spurred on technology development and engineering and accelerated our use of technology in the consumer space, I think that's been a primary key for me to this. Now the other thing is that the technology developed, hundreds of millions of dollars or even more, billions of dollars worth of technology that was developed back in the 50s and 60s and 70s in terms of computers and instruments and everything. All that technology has been pushed down to our level now. So we've actually got better tools than even in the 1970s and 80s that people had that spent millions of dollars on stuff. The Mark Slade Remote Observatory is a good example, I think. So to give you an example, the Mark Slade Remote Observatory, if you were to build it today, it probably cost about $30,000 worth of equipment and technology, plus some time and effort, to build it and to understand it. But that $30,000 today is equivalent to what well over $1 million or $10 million would have been in the 1970s, I think, in terms of capability. So that tells you that, and that's a great enabler for amateur astronomers. The other key to this is also when you have technology available to amateurs, they're very inventive. We've talked about it several times before, Scott, where a lot of new techniques and procedures and other uses for technology were from amateurs' side that had to deal with inexpensive equipment, right?
Right.
So you want to do the stuff that the big boys do with inexpensive equipment. You have to come up with ways to do it, right?
Yeah, that's right. You have to get creative.
You have to get creative and inventive and
master your craft. So
right, exactly. You got to really study and become knowledgeable about the tools and equipment that you have and understand the limitations and the capabilities that you have with what you. And I would impress upon any amateur astronomer or anybody thinking about getting into astronomy and on the technology side to learn everything you can about the equipment and to invest the time and effort in yourself, not just in the equipment, to learn it and once you learn it and understand it fully, then you can really push the performance of this equipment and you see talented individuals like Adrian and Jason that just push the limits. It's amazing how far they've taken the technology.
It's amazing. It is.
You know, so, you know, and Chuck, you know, Chuck,
Bayou.
Bayou, yeah. He's another one that's really pushed the technology.
Yeah, and you know, a lot of these people live in very light polluted skies. Chuck is something like 6 or 7 blocks away from downtown Detroit. Doug Struble is another one.
Doug
doing
Struble, right?
amazing planetary nebula imaging, and you know, again, very light polluted environment. You know, so these people have taken lemons and really made lemonade in the, you know, in an amazing way. And,
right, Maxi Falieres and Nicolas Arias too.
Yeah, again,
they push the limits.
They push the limits. People would scarcely believe the kinds of images that they make. You know, with you know, both Maxi and Nico and César, another one, is
Yes.
showing us what small, modest telescopes can do. Telescopes that don't even have drives. Telescopes that, you know,
Yes.
they don't even have astro cameras. They're using smartphones. It's just
right.
unbelievable.
You
know?
basically, so the technology coupled with the inventiveness of amateur astronomers that have a passion for the sky. And I experienced this myself when I got back into astronomy 12, 13 years ago. I wanted to see where the technology was at that time. And I just was blown away even 13 years ago, and jumped with both feet into the technology and into learning and getting the best results I could ever get, you know. And it just drives you when you see what's possible. And then all of a sudden you say, I can see myself getting better and better. And the key to that is to invest in your own skills and knowledge, and not just the equipment, but it's a coupling between the inventiveness of amateur astronomers and the stick-to-itiveness, I should say, you know, along with the technology that's available. I think that's a key. That's why this is a golden age of astronomy, I think.
Right. Couldn't agree more. You know, I often think back, I mean, as I was reminiscing over the last few years of some amazing things that I've seen in amateur astronomy. One of them I have to point out is when Jerry had read an article about using a special filter. Actually, it's not a filter. It's a special lens or multiple lenses that make diffuse starlight. And they were using this on 4 to 8 meter telescopes.
Well, they had that. They had it mounted on the Palomar 200-inch. They tested it with that. Yep, and a 1 meter scope up in Pennsylvania.
Glass with a bunch of what look like tiny. It looks like frosted glass, but it's a bunch of tiny lenses. And what happens is starlight comes through there, gets the image reforms on all these little tiny lenses onto your sensor, and now you're able to sample down to thousands of a magnitude. Okay, and you get a precision that's unreal. So Jerry wanted to learn if in fact he could do what the pros are doing with the 200-inch with his 6-inch refractor. And in fact, on our pretty much our first try on measuring an exoplanet, he was able to capture the light curve of was it HAP P16? Is that right?
P16, right? HAP
P16,
P16, right?
And we did this live. We should have recorded it in case it failed, but it didn't fail.
Right.
We actually did it live and presented the data, which later Jerry did reduce a little bit more. But the predicted light curve and the real light curve that he captured were almost identical, and so it was really impressive.
Right.
Confirm an exoplanet with a 6-inch telescope like that.
So the key is not just the detection. There's a technology level that you need to just detect exoplanets, which is pretty much standard technology with skills and knowledge at that level to do photometry, but the new thing gives you a way to model the planetary system or that planet's information. And that's what's really cool about it, is it gets you to the next level in terms of measurement for this. So I wanted to share, that was the main message I wanted to bring about the golden age of technology, is that it's really driven by individuals also, not just big science, but even in big science, you have individuals that drive it, you know. And the fact that we have so many professionals on this program shows you that they share the idea that amateurs are important to this hobby, not just to the profession and the hobby and the field, right? So, and we work together as a team, and that's another thing about the golden age of astronomy, is I think we're driving closer and closer together in terms of amateur and professional collaboration. I think we're going to have, and TESS was a big example, the transiting exoplanet survey satellite that had within the charter of the mission was to provide grounds, to have ground-based observations, a big part of the mission, and to elicit the help of not just professional ground-based systems, but amateur systems also.
Yeah, if only the dogs in the background agreed with how important that is.
They are agreeing.
agitated.
They're howling.
They're howling in delight.
appreciation.
Okay, good point.
That's right. That's right. They're making a bunch of noise for me.
Yeah, but that's I know with, as you mentioned, advances in technology and then our ability to use it and kind of figure out how to use it, you know, becoming more of a reality, but also point out that with your expertise, those instruction manuals leading the way, it does help us to get the most out of our equipment. Without well-written instructions, have a brick for the thing, it won't move anywhere, and then I just end up using it as a fancy tripod. So it is a collaboration.
So it's important that you mentioned documentation and things that training and skills and knowledge and how you get there. How do you learn about the system? And that it's not just enough to get something that you turn on and it does what you want. You have to really get in your mind that you have to learn about it to get the most out of it and to push the limits of your equipment. To me, you don't know if you need to buy new equipment until you've reached the limits of your existing equipment. If you want to be frugal, if you want to be frugal about your expenditures, you really need to push the limits and say, well, I definitely need another telescope now because this is all I could get. And you know your skills are not the limit, right? So you need to make sure your skills and knowledge are not the limit and your performance of your equipment is the limit.
Yeah, when you see Jason Guenzel getting arcs of galaxies and extremely faint stuff out to like 2 billion light years, and just features on these objects that it's mind blowing, and I applaud all of his efforts and all those hard hours of that he puts into acquiring those images, but also processing them.
Yeah, that's I think I'm impressed the most with people, that the dedication they provide for pushing this technology and pushing their skills and knowledge. Is just the dedication and the passion they have to spend hundreds of thousands of even thousands of hours to do this. And I've experienced that myself also, especially when I first jumped into this 13, 12, 10, 11 years ago. I got so hardcore into it that after 4 years, I had absorbed enough information that I decided I could write a book. So I'm not sure how many people would want to do that, but I was lucky enough and had the opportunity to be able to do that. So that's really what started me on this career in the industry. That's when I met Scott the first time in 2010. And then, I figured, well, this, and I moved into this as a career now. So it's kind of cool.
Yeah, that's right. That's right. So if the measure is you make some money somehow doing astronomy, maybe that's also a sort of professional astronomer, so, or at least a pro in the
Right.
astronomy field.
Right.
So, well, great. Thanks. Thank you, Jerry, for coming on and sharing that.
Sure. Thank you.
Yep. Up next is Adrian Bradley. Adrian has been consistently on the Global Star Party, sharing incredible nightscapes, landscapes, nightscapes, and the occasional bird photograph. Adrian loves nature, but I think he's especially in love with the dramatic views that he can get of the Milky Way. So, Adrian, I'm going to turn it over to you, man. Thank you for coming on.
Thank you, Scott, for having me on. First, a shout to Jerry Hubbell, the IOX 100 PCM8 mount that I'm using now is it has been taken for some runs, and I am impressed with the way that it's working. I'm getting used to it, and I've taken it to a couple of sites to see what kind of imaging I can do. I will go ahead and share my screen. We talk Golden Age of Astronomy, which has been the theme. And somewhere in here, I have the picture of the mount that I've purchased. And I've looked at the instructions, successfully uploaded the firmware. And so now when I power up the mount, it automatically starts tracking.
Yeah, I'm glad you got the benefit of that that feature that we added recently in the last few months. So that's a cool thing to be able to use it like a traditional mount.
Yes, and it was very easy just following along the instructions. The firmware went straight from the computer into the machine. It rebooted. Reminded me a lot like updating a server with some new code, and it came up just fine. So we took it for a test run, and I will share a couple of images that were taken using this mount. This one, if I didn't quite set it up to track, it made a pretty good tripod, but I did use it to track as well. And so here we're at one of my favorite spots, Point O'Bark Lighthouse Park. The lighthouse is behind me in this shot, and I'm aiming out at the Cassiopeia region of the Milky Way that you can see some of it coming through here, but there was a lot of light to my left. And I've shot this scene a number of times before. I would have to dig up Aurora. Whenever there's a fairly large storm and Aurora is present, this is the site through which you can see it from this park in the thumb. So let's see, this is, I set up the mount and imaged, tracking this time, and I imaged through a little bit of haze. You've got Winter Milky Way and Orion. I swear this is a part of the witch head.
Composition. I love that.
Yep, looking right up at this tower, and this little streak right here. While I was watching the while the imaging was starting, meteor came shooting down, and the tail end of it ended up in my image.
The meteors are finding you, Adrian. They follow you.
They find me.
And they start there.
Yes. This is what I liked about the shot. There's M44, and there's detail in M44. This is a 14 millimeter lens.
Yeah.
And some of the detail in M44 shows up. Now, there are thousands more stars, but the main stars of the cluster show up. Is the tracking perfect? Probably not so perfect. You can see it's beginning to trail, especially on the edges. But for an overall image, I was very happy with it. And this is just me picking it up, aiming it north, and doing a 30-minute. I think this was 25. Actually, this was 25 seconds, not 30 minutes. this was a 25-second exposure. So with the 14 millimeter lens, you don't get much trailing. If you just let it shoot, you get about 20 seconds before it starts to trail. So this tracked well enough, and then processing to get some of the H alpha regions that are in here.
It's nice to see
So-
these images because it gives you a sense of scale when you zoom up on the cluster, comparing
Yeah.
and backed out. Then you get a real appreciation for how big these things really are in the sky in
Yes.
relation to each other. That's what I like about it.
Yeah,
Yes.
that's part of what I saw in kind of marrying Earth objects. This is a pretty substantial sized tower. Here we are looking around it. I think this was just one of those where it's like, okay, I wanted to take everybody to what it looks like to be standing around this tower. There's water over here. This curves around. I'll show you the wide angle. So that's where I was standing. And behind the tower is where I was standing looking through those trees in that last shot. Here's my shadow. This is a wider view, and I'm standing so as to block some of this bright light that's created this arc here. But there's some haze in the sky at the time. Some dust lanes showed up. This was if I'm not mistaken, somewhere between 25 and 30 seconds. And you have the Cassiopeia region, and there's Cassiopeia herself right here,
Right.
next to this lighthouse. Part of what I've experimented with is taking shots like that and desaturating them. This was a little earlier, and I have the other mount that I have is a star tracking. It's a Skywatcher model, and this is earlier on. You notice Cygnus is here setting, and I think this was around the same time of night that I took the past image. So you can see how the sky moves, and the Milky Way rotates to where now it's going towards the lighthouse in a similar shot. With the haze that was in the sky, it made it to where I wasn't able to pick it up as well, but it's still there. And this is the postcard. When you zoom in and crop, you get this postcard shot. I thought this was a nice wintry. So this goes into more of the art side of night sky. You still got nice round stars, but you've got a little more of an artsy look. You always toe that line when you do photography. So try it again. And this was 30 seconds. And this was just a simple, we're firing at Sirius, but once again, the visibility of the clusters here, M41. Now with some processing, we may have lost a few stars, but M41, M46 and M47, I believe, right there. I'm not sure which one of this little dot or this dot, I believe, was M48. For those that have plate solving in their minds, they can tell me. But then, we've got this. What amazes me sometimes when I do these nightscapes is picking up these, bright Messier objects, little star clusters, and seeing them in the photo as if they, well, they do belong, but you see them in the photo. When you come from an astronomy background, you notice those things. You're not just using the night sky to try to frame, a shoreline on Lake Huron. There's things in the night sky that are actually there, and you're making your image as accurate as possible. And that was a 30-second shot. Though that was a panel. Here's a similar scene in black and white, and this time I attached another panel that contained Orion. And this is where I'm going as a part of my nightscape, landscape photos is not only shoot, these scenes using the light of the entire scene, including the light of the stars, to try and see if desaturating or black and white will carry. So much astrophotography, a lot of it depends on those colors that we pull in, whether you combine from filter wheels or you're using one-shot color. We're used to seeing colorful images, but images like this where this was a handheld shot, and I got to the point where I got the shape of the moon, but I didn't put the detail in. This is just a handheld shot, just more like a night shot. But here's a desaturated. This is something that I previously had, and I desaturated it to see what effect it would have. And it's an older photo with an older camera, but I find desaturating an interesting thing, because then you've got, if you are focused more on your subject, in which case this tree obviously is a main subject, but you've got the starlight, and then the clouds around it. This would likely qualify more as just a beautiful picture of a starry night. But if you take an image, like this, and you desaturate it, there are things in the night sky that you can see whose light carries. And I believe the image that's in the back that I'm or in my virtual image is one of those that took me a bit by surprise at how it looked. So using most of these, starting to use the Explore iOS mount. I always include an image for Scott, a blackbird against. A while ago, we had a lot of smoke in the air, if you remember. Here, we can use this image to talk about creativity. There's a lot of smoke in the air, so you could, we always say, don't look at the sun, use proper filtering when looking at the sun. The smoke provided such a thick haze that it was tempting to look at the sun because it wasn't burning the eyes like it normally does. The sun appeared, it was just a disc hanging out in the sky, and you wouldn't burn your eyes looking at it. And so, being careful, I decided I might be able to use the fact that it's so smoky to compose an image with it. So here we have the sun in the background. Because I focused on the blackbird, the sun, ended up being a little out of focus, but I ended up with this image just by noticing the conditions and taking advantage of them. So much, especially in nightscape photography, so much imaging is seeing your surroundings and using the type of creativity that astrophotographers are known for in producing images and pulling out details of images. That same creativity can go into marrying wildlife photography with a chance happenstance of, well, there's a lot of smoke in the sky, so what do? We take pictures like this. So
I think you bring up an important aspect of taking advantage, not just of the opportunities, but of every opportunity, and work with what you have. Deal, with the hand you're given, and make the best of it.
That's right.
And you can do excellent work, and you can have little oddball opportunities come along that are once in a lifetime type of opportunities that you don't realize until you go out and try. So I would encourage everybody to not just wait for the perfect night or the perfect time to do whatever, because you'll be waiting forever and you will not practice your craft. You'll be disappointed. And
absolutely. Yeah, this is the aurora. Now you notice the lighthouse looks familiar because I've just been showing pictures from a couple nights ago. But in March of 2021, I came to do Milky Way photography and saw this. So you're seeing a lot of the same angles that I took pictures of. There's that angle I was telling you about, and there's the aurora. that I saw.
It's beautiful.
So you just have, if you have your technique down, and you know how you'll take the pictures, you can take advantage of seeing something in the night sky, and rather than the moment be too big for you, you'll know exactly what you'll do to try and get those moments. And that, you know, Jerry, what you're talking about, it really helps. You know, even haze creates a picture like this where the stars bloat a little bit. There's some artistic interpretation with that as well. There all sorts of different things that you can get. I know as amateur astronomers, we tend to look at things and go, you know, well, it's too cloudy. You know, I don't want to take any photos. It's too cloudy. Well, look at this composition here.
That's beautiful. It is.
It's cloudy, but if there's enough starlight coming through and you know the starlight breaks through, cloudy nights don't have to, especially in nightscape photography, cloudy nights don't have to stop you from taking a few pictures.
That's what the added ability of being able to track the sky for long periods will help too.
Yes.
Starlight will come through almost anything. It's amazing sometimes.
Yes, it will. And then seeing phenomena like this, the light pillars, which some more others have posted their images of light pillars here. But we took this photo, gave it to the county where I was standing, just freely offered it to them and said, you all should use this for your materials. And they did. So in Alcona County's parks materials, this photo is a part of their showing what their, you know, this campground, this pond that's out at their campground. This is what it looks like. And I was standing on this frozen pond either last year or the year before when I took this photo, and the ice didn't break through because I'm here today to tell you about it. So
that's true. That's
yeah,
true.
So, and
Adrian,
not every,
thank you.
yep, copper. We were talking about copper being in Michigan. I just happened upon this image. That's copper coming through these falls. So there's your kind of an example of just how much copper, you know, is in Michigan. It's running off, it's being washed
everywhere.
into the Dequamanon River and ending up in the falls. You know, not every night. This is how hazy a night. There's a star right there. This is how hazy a night can be. This is a dark area, but it was too cloudy. But you make the most of it by just imaging what you got. You can still have a beautiful picture.
It's still beautiful.
You just have, yep.
Absolutely.
You wait till the next opportunity and see what you can get.
Yeah.
And then one last image. This one,
yeah.
It's pitch black. It's dark. I opened up the shutter for about, I think, a minute or so, and still get this. The sensor is very sensitive. Even when we can't see a thing, it's that dark. The camera sensor at a long exposure can pick up all of this data. We call it data, but it's what's out there, and can visualize it. And knowing that helps when you're trying to compose and do night sky photography of any kind. All it takes is enough time. If there's any light at all reflecting off of anything, it will show up in your sensor. The longer you expose for, the more of that data you get. And it's why a lot of astrophotographers call it data, because it's what you're pulling in. The more you have, the more likely you'll get something of an image when you're done. So thank you, Scott, for letting me ramble on.
Thank you.
Hopefully everyone enjoyed the images. Scott, I'm sure you enjoyed
They
the
always
Blackbird
do.
image.
Yeah, we all do. Thank you very much,
Adrian.
Thank you.
Up next is Simon Lewis from New Zealand. We're changing out the schedule a little bit as Simon's trying to work in some global star party with his work day here, which is absolutely, that's great. And that we have that with you, Simon. It looks dark out there right now, but I know it's daytime.
It's not. It's daytime. It's daytime.
Yes, that's right.
And yeah, sorry, it's been a challenge today. We're just back from vacation, so everybody wants everything immediately. So yeah,
Always.
Look, the theme of this this program is about the golden age of astronomy, and I'm the vice president of the Canterbury Astronomical Society here in New Zealand, and we've been in a society since 1891. So if anybody's having their golden age, it's us. But I'm not sure I would want to call now our golden age, because I don't think we're seeing the growth yet, but we're starting to see it, and certainly over the last few years, we've seen a tremendous uplift in interest in astronomy here in New Zealand, and particularly when we're talking to the newcomers into our society, what are you joining for? What's interesting? I would say that 75-80% of them are wanting to do astrophotography, which is they want to take pictures like this in the magazines or on the internet, and the images that our amateur astrophotographers are creating these days are really inspiring these people to get involved in the hobby. But I just had a little presentation just to run through here, and I'll just share this with you. So yeah, so I really think right now that we are creating. Can you see my screen? Okay, Scott, is it?
Yes.
Yeah.
Yes,
So we are really creating the next generation of astronomers here in New Zealand, and what we've been doing over the last few years, particularly around the Canterbury Astronomical Society, is really aimed at growing the hobby. So trying to move my screen here. Doesn't want to move. So this is our observatory at West Melton. So we have a few nice scopes and domes here, and this land is all owned by us. We're the only society in New Zealand that actually owns our land. Most of the time they rent from the city or councils, but what we found is that the land is extremely desirable. So they find a lot of the societies are losing their locations, which is a real shame, because they're basically cities are redeveloping them. So we've got a few domes here and some roll-off sheds and our own lodge. And we're out in the dark sky. We work with the local council, and they provide us a lighting covenants as well in the local area. And we've even got a dark sky rule around the observatory for about 5 miles. So that's really good. So yeah, as a society, we were formed in 1891. We're one of the oldest societies in New Zealand, and we used to man, when we started, we used to man the Townsend telescope. And I've got some pictures of this. This is a large telescope that's on the Arts Centre here in Christchurch before we moved out to our current site. And we were kind of dormant for around sort of 40, 50 years at the start of the 1900s. They formed up in the 1890s. The money that the society created was passed to the Arts Centre to run the Townsend telescope. And then in 1948, we restarted and reactivated as a society on our current, format, which is a not-for-profit. And we got our original site here in the 1970s, which we've grown. There's about 250 members locally. They're mostly from New Zealand. We do have some global memberships as well, but we've had a huge growth in membership over the last 18 months. And that's been in part to some of the activities that I've created for the society in terms of juniors programs and training and outreach, but also because we've been getting more involved with things like social media, which has really driven our interests. So our observatory, we've got a few telescopes. We're about 45 minutes out of the city in a dark sky location. We've got a 16-inch Meade RCX 400 on a roll-off shed, a 14-inch some smaller 11-inch Celestrons, one in a dome and one in a roll-off roof. We've got a very nice 120 millimeter Skywatcher refractor, and we've also got a ton of portable gear as well for the kids. And it's not unusual on an open night to see an 8-year-old dragging a dob out and dragging that into the observing paddock, and a few of them gathering around that and driving it themselves for the evening as well. And we've got a real nice lodge as well, which is great for overnight stays. So there's quite a lot of people that will come up and spend time there. We've got a huge number of active programs running, and this has been partly the interest as well. You know, we've got public open nights every week on a Friday. We've got private groups weekly. You know, we get around 80 to 100 visitors a week on our open nights on a Friday, around 50 on a Wednesday. And then we do, in July, we do Kids Fest, which is a schools and activities group for juniors right across the region. We get about 90 visitors there, and it's 15 nights of that. So there's a lot of, you know, we sell somewhere in the region of 5,000 to 6,000 tickets every year to the observatory, which is pretty impressive. And we got a ton of training and education programs for the kids, and society magazines and websites, etc. So, and it's only been over the last few years where we've really gotten traction online, which has driven our activities to an extent where we're growing our membership so much. So we talked about the Townsend telescope. This is the old Townsend telescope, 6-inch refractor. This is up on, it was up on the top of the Arts Center, which is this big building here that you can see with the dome on the roof. And the guys used to go up there every week and volunteer and run observations for the general public until this happened. We had a number of major earthquakes in Canterbury, and the dome and the building was destroyed, and so was the telescope. The telescope ended. These are the parts that the Civil Defense and Council pulled out of the building. This was all that was left of it. Fortunately for us, the lens cell and the lens, which is an incredibly large piece of glass, survived. Through all of this, having this whole building collapse on the top of it, the lens cell itself survived perfectly. And so we took the parts away and actually rebuilt it. And this is the tower. Just a year or so ago, they're rebuilding the tower, but they're rebuilding it in the reinforced concrete with a stone outside, stone facade to it. They've actually brought in some people from overseas to do this. It's taken a couple of years to rebuild it. And here's the telescope, the gray tube here, completely rebuilt, renovated, and ready to go back on. And that will be going on this summer. So yeah, we'll be re-involved with that as well again. How to get juniors involved? Well, this is one of the things. If you're going to grow the next generation of astronomy, you need to provide them stuff that's interesting to them. So we got juniors programs. We do little kids group before our main meetings at the university each month. Solely dedicated. They get handouts. They've got an observing log, and we get little programs and competitions for them. And they're called the Castronauts, and they really love that. And more importantly, it brings the parents along as well, and then the parents get involved. So, once mom and dad get involved, then their interest grows as well. And I was saying to you the other day, Scott, they actually teach astronomy in the schools here. It's part of the physics program. So the science program here includes astronomy. They learn about planets, they learn about the moon, solar cycles, and everything. Of course, they want to know more, so they come along to the observatory. So we do a huge amount in terms of our events. As I say, Kids Fest. We got involved in Apollo 50 and had an open night there. General weekday ones, and we do specialized private groups as well. So there's a thing in the top here, which was a private night for Aerospace Christchurch, which is an aerospace group that are involved with astronomy here. They had a private group as well. We do other things as well, like this is Stardate. So this is a star party that runs every February for 3 days. And we get out for 3 days doing lectures, practical astronomy, solar viewing. We have a big picnic and camp out for 3 days. And if you notice, there's a guy. I'm sitting on the sort of second row in on the right of this guy with the red shirt on. But there's a guy here at the end. I don't know if you could see this guy in the t-shirt or the white t-shirt at the end, second in from the lady with the green t-shirt.
Yeah.
Anybody knows that guy? That is Sam Wendt from ZWO Astronomy. And Sam came over here and I hosted him. And actually, this in 2019, this is where we came up with the format for the ASI Air Pro. So we sat down for a couple of days with a notepad and made some design ideas. And then Sam went back to China and actually built it. So
Wonderful.
That's something else we get involved
That's
in.
cool.
And there's ton of kids come along to this as well. We do all sorts of games, and they do baking and creating cookies with stars and all sorts of stuff on. The kids love it. Our local council is really important for our growth of our society. Matariki here, you'll probably know it as Pleiades, M45. Matariki here is very important in the Maori calendar here in New Zealand. And so when it rises above the horizon in July for the first time, I think it's June the 24th this coming year, and that's a start of the Maori New Year. So the local council, they got very involved. We created a whole group. We did a photographic exhibition for them. We did some talks, public lectures, etc., and got the kids involved. And they created this beautiful little sky guide and stargazing and an online video around it as well. And this culminated last year in our winning the silver award at the Tourism Awards for Selwyn District, which is where we live. So for outstanding excellence and contribution to visitor experiences in the district. So we took out the silver award, which is not bad considering the guys that took the gold award are a major commercial organization. And we stepped in front of some other big commercial operators to take this out. So I actually ran this award, so I'm really pleased and proud that we actually won this. So. We do get involved with the city council as well. So we did the International Space Party, a kids event at the library for them with rocket workshops and space and rocket exhibitions, build a space shuttle. And then we did a World Space Week exhibition as well. And you can see myself here and a couple of the other guys. We did an exhibition with some telescopes, etc., and some media. And took those along, got a ton of kids building space shuttles and printing out stickers and all sorts of things. It was great. And then we do an awful lot in the week. We do lectures of all sorts. Chris Lintott, who is a very famous astronomer. We have guest lectures from all over the world. We did an International Women and Girls Day in Astronomy. So Babak, who's a very famous
The World at Night.
Yeah, World at Night. He came over and did us a lecture as well on his tour. And of course, Sophia, who's the big NASA 747, the infrared astronomy telescope that flies in the back of the Boeing. They base themselves out here. We have a very strong relationship with those guys. They come into our barbecue every winter. They supply the s'mores, and we supply the ice cold drinks, which they actually love. So they come across as well. We do a ton of stuff with those. We do lectures and also visitors, groups, etc., with those guys. So all of these are all things that keep people interested. They get them joining, get them signed up, get them, active in astronomy, not just looking in front of a telescope, but learning and developing themselves, and they actually love that. And then this year we've done a calendar as well. So just with all of our astro images, that we've taken from some of our members. We created a calendar, and we've sold a couple of hundred of those over Christmas and New Year. So probably not huge numbers, but we've got some great feedback on those, and some nice pictures. Adrian will like that. Get a nice picture of some aurora.
Oh yeah.
So yeah. So for you know, my take on is that, you know, we talk about the golden age of astronomy. I'm not sure yet as a society.
You're not sure if we're there yet, huh?
Don't think we've seen our golden age yet. I think there's a ton more to do. And
there's always going to be more, I think. I think there's always going to be more. But you know, the kind of work that you do, Simon, also you are one of the leaders in showing what can be done in amateur astronomy. So you know, it's a great time to be alive, to see things like you know, James Webb Space Telescope go up, to LIGO, you know, us detecting the faint echo of you know, black holes, and also you know, as Navin pointed out earlier about the Wilkinson microscopy probe that to measure the background radiation, you know, microwave radiation. It's just I know that there are so many things that have gone unanswered. But we are learning more and more about the universe and about ourselves. So, which I think ultimately is what this is all about. So,
yeah, we, you know, this takes up a huge amount of time. As César's saying here, he says it's a huge challenge. There's a lot of effort, a lot of time, and you know, we've got a very good committee. But it does take a committed group to get this kind of level of engagement.
Absolutely.
You know, but to be honest, if I can get a clear night, I can put 100 people into our observatory, and I can guarantee out of those 100 people, there will be 4 or 5 that will join out of those nights. So, and you know, we can, you know, if we get a good run of weather, we can have a fantastic year. But yeah, it's been dented a little with COVID. But you know, when you get the run, it's great, and people really, really want to be. You know, we had a film. I was telling you last week, Scott. We had a film crew. You know, from our national TV turned up, and they wanted to do some video, and they gave us a 3-minute slot on national primetime TV. Wow. And we sold that. we sold a whole season's tickets within an evening. It just went mad. So
wonderful. That's wonderful.
My advice, if anybody wants to get involved in this, is, you know, get yourself, get the support, get the media, use Facebook, and you can really grow your society, get the engagement. So thanks for letting me come on early, Scott. I appreciate it, and I have to cut.
Thank you, Simon. Yeah,
I'd love to spend more time
for accommodating that. That's great. And by the way, you know, for any of the club presidents or what out there, you know, whoever is watching this out there, the speakers that come on to Global Star Party are world class, and you know, you can probably just give them a friendly email and to get them to speak on, you know, about their club or their projects that they have going on. But you know, amateur astronomers love to share. So
absolutely,
thank you so much.
If anybody's interested, I'm more than happy to talk about it. So that's cool. Cool.
Thank you.
Have a nice day, guys. Thanks.
All right, that's great. So let's see. Let's bring Nico on. Nico, thank you for hanging in there with us. And you know, we have Jerry and I know you guys were, you and Maxi and César were there in the background, and we're all talking about you guys as if you know that, you know, whatever. But we are all impressed and in awe of what you guys do, and with your telescopes and with your gear. And so I look forward to your presentation, Nico.
Okay, thank you, Scott. Hi, everyone. Hope you are having a great night. So let me share my screen. Here we go. Can you see it?
Yes.
Okay, tonight's topic is about the Golden Age of Astronomy, and as we always talk about that, I saw this Golden Age, as Sherry says, with the technology and the possibilities for the amateur astronomy. Now we have all the tools and the softwares and the internet to learn and to get involved in a lot of things about the astronomy, and especially with low budgets. You can do a lot of things in your home in a contaminated skies. And okay, I was thinking about what kind of things I think this is the big important the technology bring us the amateur astronomers, and I thought about the astrophotography, planetary imaging, and science contribution that you can do with any telescope you got and with the small cameras. And let me show you. I will start talking about the real science contribution that you can do even with a webcam, not even talking about small cameras for telescopes, just a webcam that you can simply remove the lens, put in a small telescope. Here, this was an old 70 millimeters refractors I had with the webcam, and here is the same webcam with my my 10-inch Dove, and I used to do double stars measuring and publishing the papers all with a webcam, and I think this is it's great to encourage the new astronomers and amateurs around the world that is beginning and they have the first telescope and they want to do something something more, something to make a small contribution in science, and you can do it perfectly with a simple webcam. And we have also the softwares that are this software is Reduc, is especially for double stars, but you have software for variable stars, for photometric, for astrometric, and there are free softwares, and there are some software that you need to pay, but with a small budget you can get it. This is some publishes with papers about double stars that I made. This is the first double star I discovered from my home, and you can do this with a webcam or a small guiding camera. You can do a lot of things. Talking about planetary imaging, as you know, I love to do that with my Dobson. As you can see, this is a real video from a capture of Saturn that I made with my Dobson. You can see the planet driving in the screen, and there is my correction, my hand motors, because this Dobsonian has no drives. And again, you have a lot of softwares that simplifies. You need to learn to use that, but this simplifies the work, and it helps you to get amazing results. This was with a QHY5 camera, monochromatic, is a guiding camera, and I use this to do planetary imaging. You can see the results, and this is with a telescope that you don't even need an equatorial mount. So with a small budget and the telescope just you can do a lot of things. And well, to finish, I like to talk about astrophotography. Sometimes I do some photographs, sometimes with my Dobson, but I have here a few examples that you can do with a 6-inch Newton in an equatorial mount with the same camera, with the guiding camera. and here's the Horsehead Nebula from above the night skies. So when I took these pictures, I cannot see anything in my screen. So then when I stack the images again with all the softwares and all the information that you can get today in the internet, you get this kind of images, and it's amazing because with a little camera, you can do even astrophotography. This is another example. This is my last astrophotography of the HEC 1355 galaxy. This is in Fornax constellation with the same camera, and this time I use RGB filters and common RGB filters. Just do 4 captures and then stack and join that, and you can get this even galaxies from the city sky. And this is my, well, we are starting here with the Orion's times, and I do my first try with Orion with M42 with this camera, and I was shocking when I started capturing, because I cannot do a longer exposure than 10 seconds, because this happens, the centers go all wide. So this was my first try. You can see here the 4 channels. The L channel is without filter, and in the others I use the RG and B filter. And this is the result. And it's mind-blowing that you can do this from your backyard with a small guiding camera, and there is no excuses. We are really in the golden age. It's obvious this will still keep going, and in a few years, I cannot imagine what we can be able to do. But today, with a small camera and a small telescope, you can do this marvelous image. So, well, this was my short presentation about this amazing topic that we always like to talk about. I cannot hear you, Scott.
I can see you,
yes,
Nico. Yes, because we are in Argentina. We are close. No, don't function in that way.
Okay. Oh, I cannot hear you, Scott, but can you hear me? Yes.
I can hear you.
Okay.
Scott. Okay. I can listen to Scott.
Okay. Well, when we wait, Scott fixing their mic. No, we can hear you. No.
Hold on. How about now?
Oh,
there we
yes.
go.
There you
we
go.
Okay now? Okay. All right. So I just wanted to say that the shot, your Orion Nebula shot, reminded me of the first image that I saw of, well, not the first image I saw, but the first image actually made with the Mount Wilson 60-inch telescope was done by George Ritchie with with a 4-hour exposure. And your image with your small telescope has more detail, is richer, is far superior to that image that was done with the 60-inch telescope back at that time. Now, of course, that's back at the early part of the 1900s, but and a lot of technology has caught up to us by that time. But it is amazing where it's come so far, and we can only imagine what's going to be coming next.
Yes, that's the amazing that you talk about in a 20 or 30 years, the big jump that we are able to buy a small cameras or something in our homes. This M42 picture was maybe 30 minutes at most of integrations. Is really mind blowing.
Okay. So let's have stay down in Argentina and move over to Maxi. Maxi was getting his dinner, I think.
Yeah.
So
I had to get dinner, but I'm here right now. So how
you're
are you
here
guys?
now. Yeah, it's great to have you back on.
Hola, Maxi.
Hola, César. Nico.
Hello. Yeah.
Yes. So let me,
hi, John.
Yeah, hi.
Well, yeah. Do you hear me?
yes, we hear you just fine. We just hear you just fine.
Excellent.
Maxi, for those of you who have not familiar with Maxi, he's been on many global star parties so far, and he is also someone that showed us some amazing, remarkable images that he made with a modified smartphone. But since that time, Maxi has shown us what he can do with astro cameras, and he's a very dedicated astronomer, also dedicated to educational outreach to the public out there. So it's wonderful to have you on yet again, Maxi.
Well, thank you, Scott. And well, hi everyone. Good night. And well, tonight what I'm going to talk is about what I've been doing these weeks that we passed. Last weekend I went again to Alberti. That I called you Scott in a moment in the middle of the night, and we spoke a little about, well, I was taking pictures of the comet that in my back. This is practically almost 10 minutes because it was really, really low, and also the moon, it was getting shiny. But then I start to do some outreach and get more pictures. I try to do and work in 2 different points. I want to do obviously with my telescope, the astro camera, and also with my DSLR camera with another mount to take a good field of view from the southern sky. So let me share you my screen. Okay, do you see it?
Yes.
Well, I think I want to show you also more later a resume that I did a little video with a music, but I don't know if Facebook is going to allow, because from copyrights thing and all that stuff. But well, let's begin. I started, well, I went to, this is the National Route 5. This is the road to went to Alberti. This is a really it has a huge
Very transparent.
No, but a huge transit of trucks and cars. But this Saturday, it was almost nobody, you know.
Oh, it's
And
empty.
yeah, and well, I been there. You know, this is the sun. This is a milk factory, but I was almost in a half hour, almost, and this is me in the really happy because well, the sun was getting down. I started to have some smoke in the place, but then goes off. So let me see if we can see the video. Let's open this, but stop. and let's stop sharing, and I want to share that screen. Let me, if I can get allow. Do you see it?
Yeah, you see,
Yes.
we can.
Okay, let's see if the sound goes on.
Yes.
Well, do you like it?
Amazing video, Maxi.
It was a short
Muy bueno, muy bueno.
edition that I did today. Well, I started yesterday from processing that images, and well, you know, the that night was amazing because the night was so clear, and I remember I was taking picture with a telescope and another place with a DSLR, and then I put the cell phone to get pictures with long exposure of all the place in the night, illuminated by the light moon, the moonlight, and you know. Then when the moon goes out, I start to see a really huge fireballs down in, but really long fireballs crossing almost to the to the well, I don't know if I have a picture. Let's close this. And the cell picture, I don't know, it started to go here, this, almost there. This line is nothing. What this is, I think this is when it started. This is a fireball that starts to shining, but I couldn't take it in that field of view. But it was really long and really golden light has, and also was really shiny, and you can see also the that smoke that leaves. It's amazing. And then I also saw another brightening, like a very, very white, and then a few shortlies. So the pictures that I took, of course, well, one I started with the comet Leonard. I think this is my last picture because now it's getting more down and it's impossible to take a picture from here. But I love to take this kind of well, I think this the sodium tail, because it's more whiting than the rest, and of course all the shapes that has. And I love, you can see here is a little galaxy, and another here I think is another one.
Oh, yeah.
I think this is my
Beautiful.
bestie. So then of course with the DSLR I take the well, this is a stacking image of the southern sky. More down here is the Southern Cross, but here we have the Carina Nebula, the Southern Pleiades, the running chicken nebula. I don't know what it calls like that. And this globe, I think they are open cluster, but there are too many stars in there. And maybe the next time I will take pictures from this place, because you have a lot of sun in your hands, or shining diamonds, you know. It's amazing. And also watching through a telescope is lovely. And also we have the Great Magellanic Cloud. Here is the Tarantula Nebula. And here we have the small Magellanic Cloud with 47 Tucana. And I was taking pictures, of course, of the Tarantula Nebula. In this case, with the telescope and the CWO astro camera. And also you have a lot of globular clusters in this galaxy, but you can see all the dust it's around this place and all the colors that has it. It's amazing place to, if you go here to the south, to watch it and also to take pictures. And then I was thinking of what place to take, but I decided to go to the Carina Nebula because I was taking that this picture, and this is I edited this yesterday, I think. You know, here's the keyhole, and behind this star is the homunculus, but it's really, really shining. And if you're taking pictures in long exposure, it's impossible to take it. And you can see that there's a lot of clouds and nebulosity floating, like if this was a lava lamp.
Yeah, it's beautiful.
And
look at all that. That's all star forming region, you know.
Really condensed.
Yeah.
That here's more down here. You know, you can see this is floating. It's amazing.
Bark globule.
Yeah. It reminds me a little the Lagoon Nebula for the colors and the Trifid Nebula, but there's a lot of shapes. And well, this is of course the visible spectrum. If you have an H alpha filter, this will be really, really red, and there's a lot of things that we can see right now. But anyway, I try to it looks like a little blur, this picture, but I think it's more because the dust has in this place. But because if you go here, you can see also the dust, but then you can start to see the darkness of the space. And I think it's because of that. And I really love this contrast. It's amazing.
It's beautiful.
Well, I did these pictures, and also I try to take pictures of the Dolphin Head Nebula, but I couldn't. I think it was this one. No, it was no. I didn't save it, but it's, I think it's this. Yeah. In this picture, you can see it's a lot of stars, but here up is the head of the Dolphin Nebula, and this is the mouth, and you can see the part of the down. It's almost visible because I don't have oxygen filters. And then I try to do pictures of the three galaxies of Leo, and because I want to see how the field of view was. And this is a single frame in 2 minutes. You can see it's a lot of information in only 2 minutes. And I hope in a couple, maybe weeks, I could get here again and see what I can get. So, well, this is my little presentation. I hope that you like it. And thank you again for inviting me.
Thank you very much, Maxi. That's great. We're going to stay down in Argentina and bring on César Brollo. It's always great to have the astronomer contingent from Argentina. You guys make a great program every time, and we're really honored to have you on. So,
and it's an honor for us to be here in the Global Star Party, and really we appreciate that we are Maxi, Nico, and me from the same country, and show to the people what are we having and making from our skies. Of course, Maxi and Nico make the magic. For me, I am only a telescope dealer. I'm some technician, you know. But
you take images too, and
yes, I am the guilty, like the telescope dealers in that. But for me, it's a pleasure how many amateurs make magic with their telescopes. Well, tonight I have a little presentation of a little of my history about how I can watch it in many years, some changes of technology in telescopes. You know that, Scott, that I am started in to sell telescopes in Argentina. I was the first one in a time where the people don't know about the Cassegrain telescope. I remember that I started to show the Schmidt-Cassegrain telescope. The people think, okay, where is the another part of the telescope?
Yeah,
it's too short.
Something's missing here.
Yes. The first thing that changed a lot for the people, we talked last week about the Don't Look Up, the movie Netflix, is that the people understand more about astronomy in that movie. The things about how astronomers find comets are really near to the reality. If you see a picture from the 80s or 90s, was more science fiction, and today the facts are more real. The first connection of the Golden Age of Astronomy is, of course, despite a lot of very, very ignorant people that don't like to know about nothing, you know. It's not only astronomy, science, but a lot of the first thing that I can see in the last 30 years is really more people are interested in, to know astronomy, and the facts that they know are more near to the reality. Of course, that you can find people that love in magic thinking, you know, but more people every time it's more concerned about the real ideas of how planets or, you know, telescope works. It's really, if today when many people came from our store, have more information, maybe by internet or they read something more, you know, but they don't ask me anymore about where is the another part of the telescope with the Schmidt-Cassegrain telescope. If they, I remember that when I started.
So you had a big responsibility in your country to educate people about amateur telescopes. That's really remarkable, you know.
Yeah, yes, it was
that's really remarkable. I mean, you know, of course, everyone that is in our industry that sells telescopes, we are
of course that
people about this stuff. But
sure, today I am not anymore the only one. Here in Argentina, when you have a successful business, everyone goes to copy you. Like right. Everywhere. Yes, and today I don't know how many dealers, telescope dealers exist. But for me, I'm proud to be the first. Today I am more concerned to enjoy the life, you know.
Right.
And but we are growing again despite the crisis. We are working in a new aspects of the business. The idea, I'll share my screen to share this presentation with a little of humor, of course. I say that it's golden age of amateur astronomy too, because it's the golden age of amateur astronomy. But of course, the professional astronomy is going to be an amazing results with the Webb telescopes. We had 2 or 3 decades amazing with the Hubbell telescope, and we had a lot of different discovers in astronomy. But from my view, how the things changed in this time, in my 30 years of career selling telescopes, repairing, you know, and a lot of things more, maybe being a lecturer for the kids or to explain things. First I found my first picture of Orion with film in 1994. I used a mount that I made. I made a mount with a motor, electric motor, and my first Orion nebula with a film. I remember that I used one completed film, and the best pictures that I could take was this with a small telescope, only 500 millimeters focus, mix between a Cassegrain. I remember that was a Conus brand telescope, maybe from Japan, you know, maybe a Towa or Kowa manufacturer from Japan. Maybe you remember in the end of the 80s,
oh, sure.
and first time of the 90s. Comparing with this picture, the last picture maybe a few months ago that I took only only to try in my city sky, and comparing this and this is incredible. This is talk, the pictures talk about in 25 years how astronomy changed. Of course that I could take a lot of pictures more of galaxies like Pavo Galaxy or Dark Galaxy. The moon, of course, people can take a lot of different people from the moon very easily. And first of all, we need really good quality and average clean optics. Please don't use your telescope as a fish tank. And this is why. This is my remembers from my technical repair optics, and this is a part of my history. While the optic change, the things about this is a mark of the level of the water.
Oh my goodness!
Reverse, yes. I think that this was, yes. I repaired a lot of different things in our laboratory. I think that this was in 2005 or 7. I think that was 11 inches. This was yes. Of course, that the telescope was in a reverse position and was totally filled at this line of water.
Wow.
And the owner don't have an idea. Of course, with a huge rain. That with the wind that opened a little the dome, and with the wind and the water, when you have exactly the wrong point where the drops, not the drops, a fall maybe, a cascade, going into the tube. And for example, this was
and it filled the tube up with water.
Absolutely, yeah.
Oh my goodness.
Yes, this is real.
That's unbelievable.
Yes, if you are interested in botanics, a telescope can be a wrong place. From the same telescope, I think. Here, you have a lot of mushroom. Yes, fungus. Yes, yes.
Oh
my another specialty, biology. And this was the telescope was ready. Actually, it's working. This is something that is great for me, that all telescopes that I received to repair are working actually. This one is another one that was completely in a flood, completely in a flood, totally in a flood
for a long time. It looks like
for maybe 15 days underwater.
Good Lord.
And you cleaned it up. You cleaned it up and fixed it up for him then?
Absolutely, yes. Actually, is the owner is making pictures with this telescope. I can show you later some picture of this guy for Fernando Ricardini.
That's amazing.
Yes, we bought the telescope to our customer because my customers say, okay, I give you another 5 inches tube that we repair and I can change. And my customers tell me, really, you can accept that was underwater? Yes. I'm cleaned. We painted, of course, the mechanics. We repaired the focus mechanic completely. And actually, this is part of this assembly that we made this in maybe 2010. This is completely disassembled plate, Schmidt plate. The telescope, this one was assembly again, and this was the secondary mirror. This is another stuff that we made for our customers. I made all time. I made the ridiculous things.
Tracker.
Tracker, awesome. Yes, for an old Nexstar SA mount.
Yeah.
That is incredible that the go-to mounts are from 2000 in Celestron. For Celestron was in the end of the 80s, they started to work at the with the Campus Start. They go to a very first time go-to telescope, and the LX200 in the time of Scott Roberts in Mead, where they made a wonderful go-to system. Before that, they used a Magellan system that you needed. Maybe you don't remember when we need to move the telescope and see the numbers to go into zero when you get the point, the start. Was the population of this is another telescope with rain, with a broken roof and all rainwater over the
all over the corrector plate.
Yes, I remember that. Yes, absolutely. And I remember that I needed change a lot of electronic parts that was full of water.
Right.
Yeah.
Can okay, that's let me ask either of you, Scott or is anybody ever tried to, what do you do about a cracked corrector plate? I got someone in our club that dropped theirs and it's cracked.
Okay,
yes, yes.
Go ahead, César.
Yes, it's something that if you broke the plate, you lost.
It's no good.
Yes.
That's what I told them, but
yes, because you have the shape of the Schmidt plate is so complicated because it have well, talking for the people, sorry that I don't have a scheme of that now, but having a special deformation shape to work in the opposite spherical aberration. One day we can talk about optics. That is very interesting to talk about the different things of optics. Here you have a mid. I repaired mid 2. This is the second generation of mid, much better than the LX200. I think that this was a Richie Cretier or a Planatic optics with great go-to optics too. Look, something that my old Motorola smartphone. It's incredible. In 10 years, you think that the technical of telescope is so different, and the smartphone too is something that was going in a different way, but the technology is incredibly fast. Actually, well, this is the Explorer Scientific that I cleaned it a little. Of course, I with the apochromic refractors, I have a better life now. It's only to clean a little, a little of air, no more complications with water. No yet. No,
not yet. Not yet.
No yet. Not yet.
Give them a chance. Give them a chance.
Yes, sure.
Somebody will leave them out. Yeah.
Yep.
Yeah. Something that we make, that we love to make, and we don't make actually, especially look the size of the rings to support guided telescope. Another thing that in the only 10 years ago, we needed huge telescope guider because the sensibility of the guider cameras with Maxi was a kid. We needed a huge telescope. Today, all is 30 millimeters, small guider. I remember that we started to manufacturing the rings for guider telescopes. This was the finished product made in Argentina.
Very nice.
Yes, and we look the size of the guidance telescope. Today is not more necessary use this size of telescope.
Celestron Astromaster 70. How about that?
Yes, I made aluminum boxes too, made in Argentina. No, yes, it was a great product. Yes.
You can make it all, César, from
Yes,
observatory domes to cases to
yeah.
all these accessories. It's great.
Sure.
Replacement optics, even.
It's
right?
amazing.
Yeah,
it's a
this is the
one-stop
part
shop.
of the tool shop. Yes, it's a nice place. It's where I have fun with my father. Actually, I told that my father have actually 85 years old. Really, he loved when I have some project. I say, Papa, we can make new, some adapters or customer needs something like something to put a telescope over another mount, or everything can be made. And here, well, sometimes I put a mirror and green the mirror or polish. Is my old draper machine from my 16 years old that made my father for me in my
wow,
when I was teenager. A real sign of the creation of astronomy technology is about more and more people go to have a telescope. Yes, yeah, this is real. This was real from the early 80s. From the 2000s, when I remember that we crossed the limits to receive one track of telescopes by each, and the problem is that unfortunately here is our showroom where suppose that it's only for telescope, and we receive a lot of boxes, and we had a lot of boxes in the showroom because the warehouse was totally full. Actually, we are changing the warehouse. We put in the similar way the Explore Scientific telescope, because we import a lot of natural 450 inches, and we have the same problem today. That is, we are happy return to don't have place to put the boxes. Here is another thing of how the technology changed. In 2007, Celestron developed a Unity for the Sky Scout, and now you have all of this in your cell phone. But it was very interesting for the people to have something to appoint to astronomy. It's incredible when you think that really I sold this 2 years from. It's incredible. It's incredible. One day I remember when started the rebellion of the machines, like a Terminator. Yes.
Like Terminator. Okay.
Yeah. Absolutely.
Oh my goodness.
Yes, when from I think that from 1997 we start, not a little less, a little later. Sorry, from 2000 we in our in our repairing facilities we started to work with go-to mounts and repair it. Was a nightmare at today, and this is the rebellion of the machines. Here, for example, I remember broken, for example, things like broken encoders wheels, or a lot of different stuff where they say, okay, motherboards and more motherboards to change or weld, or you cross cables. Yes. Many customers say, okay, I disassembled this. I don't remember where is. Yes, this is. I think that this was from a quarter mount. I don't remember what, but a lot of electronics and things the servo motors. Today we are working more with step motors. Another Nexstar mount.
Nexstar.
Yes, a huge history.
Well, I got into one there just a few months ago. At not that level, but I got it working. And then, but the thing was, it was a little the little 4-inch Maksutov.
Yeah.
And he left it in a really hot location, and the entire little secondary thing, or the little shield around the secondary mirror spot, had fallen off down onto the main mirror. And so I actually
had that experience.
You had that happen too? Yeah,
absolutely. The Schmidt Cassegrain that we bought for us for the staff, the underwater Cassegrain, we call it
underwater Cassegrain,
the diver of the flood. In a trip, when you put a telescope without, with the vibrations of the cars, a very long trip, the completely secondary was
a little baffled secondary shield. Yeah.
Boom. Yeah. Fortunately, I don't know why was not broken. Only knock the tube, and the people I was in a show on an astronomy conference, and I repaired the telescope, and remember the astronomers watched me really scared how I put the telescope, and I collimate maybe 15, no less, maybe 5 minutes. And when I put the telescope with the camera and project with the projector in the screen, the people say, how can you make this? And we are watching Jupiter, and Jupiter is really great. It's the experience. It's the craziness, absolutely. And well, something unexpected for me that is part of the golden age of astronomy or amateur astronomy is the connection with the technology, with the kids. It's something like a green laser, red laser. Here, the laser was for another thing that, especially astronomy, was for talking about optics, for example. We went, some part of our work in our company is to be a sponsor for third parties. I don't need that for because you can be a sponsor and say, okay, you can show something or solve eyepieces in a pop-up. But no, I like more go to the people and explain to the especially when we make third parties with kids or college. In this case, something of technology is around astronomy. I could talk about optics with the kids and explain many things. This was very easy with how technology is every time cheaper, and you can make things that 30 years ago was impossible. For example, here I can explain optics to the kids, give them prism and mirrors, and they can resolve something like labyrinth with putting the mirrors, using the idea of reflecting limit in a prism. Sorry, my pronunciation about prism.
Prism.
And,
prism.
Yeah.
Here
right. You can see better, and I prepare sheet of when the path of the light and they can resolve with different mirrors and prism the path, and was amazing for the kids and for their teachers. And I remember that the teachers was totally amazing, and with that, and of course that we give a lot of these equipments of prism and paper sheets, and for the college, because the schools, because they was totally amazing with this, especially in a country where you don't have, here we don't have all the things for the schools, because if you read something about Argentina these days, they say, come on, how is possible? About our economy. And here in the same event, talking about technology, well, the age of computer, camera, solar telescope, really affordable. This is something that is magic. You can make a lot of things for explain, to show, to enjoy. It's something that really we love. Here, it's the telescope. Was one time here it's the telescope that the diver telescope, repair it. Here one more time, the diver telescope.
The diver telescope.
Diver telescope. Yes, actually, yes. A customer bought. His name is Fernando Ricardini, and he took amazing pictures with the diver telescope. I'm really happy to repair that the telescope still working.
It's great.
Yes, here the kids in the area of very near to the eclipse area in Las Grutas.
Yes,
where Maxi was too. Some pictures that, well, photography, this kind of pictures like Maxi show in his presentation is something amazing. I remember that they have a picture from the 90s from the galaxy, and I needed 20 minutes with 800 is ASA to make something less than this with a film. Yes, it's so different now. And well, this is when we changed a lot. We started to make the show using a telescope and projecting in a screen. Here is a live picture, live image of 47 Tucana, and the kids say, "Wow!" Their teachers too say, "How this is real? It's not a slide. No, it's real." We started to show this and make this in a live in 2000 when we used a CCD with 3 different colors and started to make this in live with public. And this was, we was really the first to make this with the public. And this is really a real technology. And this is in the end of the 7, in the 2007, I think, we say, why not we can take a picture of the organizers with we keep the screen and put the projector to a wall of salt because it was in a salt field. Salt, like, you know, salt field. I think that is a salt field, salina in English, I don't know. In a place in Las Grutas where you have 47 Tucana, stars are the organizer of the event in the same picture with the same time. And this is incredible. It's something that you can talk about how the golden age of astronomy is, because this is a live image. This is the sky, and here you have the people. It's not 3 different pictures, it's the same picture, and this is really great. And this wall of salt have maybe 9 meters tall.
It's I think it's saline.
Saline, maybe, I don't know. I don't know in English how is the name where you can.
What do you think, Scott?
What's that?
Here is a mountain of salt.
Yes.
Salt, like sodium chloride, or I mean,
Yeah,
okay,
exactly. It's
like rock salt, basically.
Rock
Uh-huh.
salt, yes, yes. They put they made
Interesting. Wow.
a big amount of salt, and it's like a rock. Yes, it's very white, and we use this to project the 47 to 47 Tucanae in the salt wall. It's amazing. It's
On that
something
white salt wall. I'll be darned.
White salt, yes, yes. It's something that is magic. And some of my setup in home that we know that that I show many times in the global star parties. And this is talk about how the setups for cameras, mounts, are incredible. And you have many different things with a smaller equipment, with more smarter connections. And really, we love this age. I love this age of astronomy, really. This is in my top roof of my tower. Here from the window, also the astronomy turns so easy to take pictures, to enjoy. Here, it was more very, very cold and humid night in Buenos Aires. I put the computer outside, mount the telescope in my balcony. I'm working with my it's not an iPad, it's an Android tablet to work with the mount, and here with the phone to work with the computer. I don't need it. Yes, to make pictures without the cold weather, and this is something that is amazing. And this is the end of my presentation. Thank you very much. Maybe Scott don't see that.
Thank you. You do need one for you.
Yes, I need one.
We'll have to work on that.
César,
I want one too.
You want one too?
Yeah, yes. Well, this is
wonderful.
Thank you.
I always enjoy you too. Yeah.
Yes, absolutely.
Right. Okay. So
what do you think, Scott? It's kind of do we have quite a few people online?
We have time. We have time, John, and you're on. So
I didn't know how much you wanted me to present. I finally got around to brushing off an old PowerPoint I had of a presentation of what the star party really is all about. I don't know if you want me to run through that, or
if you'd like
it may
to,
take 15, 20 minutes. I can go through it pretty fast. I got neat pictures. So what do you think? Should I
think you should let it rip.
Let it rip? Okay, let's see if I can. Okay, I'm going to have to share and then switch into the PowerPoint, right? Let's see if it'll work here. Okay. How's that?
No.
Okay, hang on. Let's see. Okay, we're getting there. Let's see from the beginning.
Excellent.
Now, how's that?
It looks good.
Okay. Now, let's see. With that, I can't really tell if I can see it, obviously, but I can't see any of you. So I guess that's the way it works. Right?
That's the way it works.
Okay. Well, anyway, I grabbed your picture. I hadn't looked at it till later this evening, and I saw, oh, well, we'll start with that.
Sure.
So a little bit, we're the Nebraska Star Party is a fully registered 501c3, we call them in the United States, nonprofit organization, chartered to promote and encourage both public and private astronomical observing activities through dissemination of educational information pertaining to astronomy and related sciences, encourage dark sky friendly outdoor lighting practice into the state of Nebraska. Sponsor an annual star party at Merritt Reservoir. It's about 30 miles southwest of Valentine, Nebraska. There's a typical star party. Well, not.
John, we don't see the presentation. We see the software.
Yeah, just the first slide. Yeah.
Yes, maybe you can change. You can see.
Hey, please move window away from shared app. What's that mean?
You can stop sharing.
Oh, there you go.
Start,
Now you got to
if
the
not,
second
it's
one.
okay. This, yeah.
Okay. Now.
Okay, but that's not. Yeah, let's see. When I hit to go through the slides, it goes to full screen, doesn't it? Or will it-
You should put it in presentation mode if you want.
That's what I thought. Let's see here.
Maybe yes. Maybe. Current slide.
At the bottom right-hand corner, if you move your mouse towards the bottom, you're going to see a little, looks like a screen. Right next to where it says 47% down here.
Yeah.
All the way at the bottom, to the left.
There.
To the left of that. No, to the left of
there.
Where it says 47%. There's an icon that looks like a little screen. That one. That takes it to, that should take you to presentation.
Yeah, but I think
That's
the
gonna work.
software is not allowing to show the presentation because his presentation the PowerPoint only without the slide.
Maybe yes, or maybe do you have another screen to because you can choose which screen share, and we can stop and start again. And do you have this window, and you have another window with
I only have the one screen on.
Yes, yeah. I think.
Well, okay. Can you see it this way?
For us, it's okay, but
it's okay.
You can see that.
It's okay. Yes, you can.
Except all the little fancy.
That's all right. That's all
okay.
right.
Well, I went through that one. Let's see if I can.
The very important for the people is go to Nebraska Third Party. It's all
that's right.
Absolutely, John. Yeah.
Well, I know, but okay. Let's just. That's what we're all about. That's actually one of my telescopes.
Yeah.
Well, we've modernized it a little more than that. But,
yes. Well, from the golden age for astronomy to the
back in that time, that was kind of a golden age back then too. With the start of amateurs actually having telescopes. Yeah. Gathering with people from all walks of life that share a common interest in seeing the night sky as the Native Americans and early pioneer settlers saw it. Sandhills are an area around the Merritt Reservoir in north central Nebraska, provides a location yet today that is a premier dark sky site. There's where we are in the state of Nebraska. I live down here in Omaha. It's about a 6-hour drive up to there. And right there in the next slide, you'll see is where we hold this event.
And it's in extremely dark skies.
So where are we? Have you ever noticed on a weather satellite image of the Earth taken at night? Everyone usually goes, oh, isn't that pretty? Just look at all those tiny points of light shining out into space. And that's what you see. Now, however, let's look at what all that light is really doing to our ability to see space from the ground.
And this is something that is fantastic when you see the things over the horizon and you start to see the sky over the horizon. Sometimes the Milky Way, when you see over the horizon, you say it's magic because you have another perception of the.
Well, and Scott can test up there. Yeah, the stars, you can see stars right down the horizon. Well, there's, of course, the whole United States, and you see anything east of this line that just cuts through western Nebraska, Kansas, Oklahoma, eastern Texas is almost totally obliterated with light. Zooming in, here's this little dark hole up here in north central Nebraska. Zoom in a little more, and the X marks the spot where we hold the annual star party.
That's in the black.
Amazing.
Right
in the black.
In the black, yes, like Alberti, Maxi.
That's basically Bortle. Yeah, Bortle 6. Yep. Okay. Why do stargazers go there? travel thousands of miles to this remote area in Nebraska. Let's take a look. Now this probably, yeah, I had a video embedded and that's probably not going to work, but we'll move on. I got other pictures. Why are we consistently rated one of the top best star parties in the nation? We got unbelievable dark starry nights, spectacular scenery of the sandhills. Yeah, we don't have mountains and big tall trees, but we have some spectacular scenery up there. We're very family friendly event oriented toward the beginner. A chance to look through some unbelievable telescopes of all sizes and designs. And we advertise no telescope required for anyone that wants to attend. Activities other than stargazing, you can go fishing, boating, hiking, swimming at the Merritt Reservoir, canoeing, tubing on the Niobrara River. Go to the Valentine National Wildlife Refuge and see native North American bison roaming freely. It's close enough for a day trip up to the Black Hills area in South Dakota in the Badlands National Park. We emphasize on education. We have an astronomy beginners class, 3 2-hour sessions during the week. Learn how to locate the constellations, binocular telescope fundamentals, get the most out of the equipment you have. Learn how to find interesting objects in the night sky. Continued on Wednesday, we have a full series of lectures at the Valentine High School in the town of Valentine. Knowledgeable speakers from around the country on relevant astronomical topics. We also have a children's program of K through 7th grade to pique interest in the sciences, safe viewing of the sun, learn the major constellations, promote inquisitive thinking and discovery. The beauty of the night sky from up there is really unbelievable. Pictures do not do it justice, but here are a few.
Wow.
Yeah, there's the dark spot in the
That's
southern
dark.
Milky Way.
I remember seeing my shadow.
Oh yeah,
from
yeah.
the Milky Way on the
Easily.
ground.
There's a wide angle. There's the only little tiny Luma glow. Of course, this is time exposure. You can see the RV recreational vehicles parked and the red lights around them, but you get a little tiny glow. Now this stuff is the greenish air glow in the sky. I guess you could call that pollution, but that's natural pollution, natural, not artificial pollution. But there's the Andromeda Galaxy. And that's probably the double cluster between Cassiopeia and Perseus coming up there. There's
so beautiful. See the Andromeda Galaxy.
Yeah, well, I had the same thought.
For me, that is
for you.
I remember. Yes.
And of course, I had the same feeling when I see you show the Magellanic clouds and the
Magellanic
Nebulae.
Absolutely, John. It's the same kind of sensation. Yes.
But there are some beautiful shots up there, and we even get an occasional aurora.
Wow,
that's pretty good. Yeah,
really.
Looking north, yeah.
It's not so to the north, but you can see
it got so bad that we were complaining because we couldn't see the deep sky objects.
Yes, because Nebraska is more in the middle, but it's incredible that like you have a really dark horizon. You can see.
The horizon. Other than that,
horizon
over there.
Yes.
Yeah. Mm-hmm.
Yes,
and it's also
so dark.
Leads to some incredible sunsets. And it's the whole area is we call it the sandhills, but it has native grasses growing on all of it.
Mm-hmm.
Here's some of the big Dobsonians that are set up. There's an area this is in a state park, and there's an area about half the size of a football field, a U.S. football field that has been covered with asphalt. So it makes it very nice to set up the big scopes and sit around and look there.
Something that wow. Sorry, John. No, sorry.
That's right. This is another thing. The people that you get out there that live entirely in the light polluted cities, they see these awesome thunderheads build up, and it's just like, oh my goodness. It almost looks like a huge nuclear explosion, but it was a big,
absolutely a big storm.
Thunderhead.
There's a lot of power
storm.
there.
Fortunately, that one was about 100 miles to the east of us, so it didn't bother us that night. But occasionally they can cause some problems up there. But Okay, here's the. I always
Wow.
like to throw this one in.
That's cool.
Yeah,
Look at that.
we don't do that much because there's less and less people that bring, homemade, so to speak, other than the
Yeah.
big Dobbs and some of them. But
Sure.
but he got first place in this division But isn't that kind of unique? I mean, it's just a little
That's very
60
cool.
millimeter refractor, but
Yeah.
they've turned it into a very nice, stable platform. It was.
Oh, yeah.
It was a fun
Absolutely.
thing.
Yeah, if all 60 millimeter refractors were sold on
Yes,
mounts like
but
that,
this
On a
mount
mount like
are
that,
much
yeah.
better
Yeah.
than the original.
And-
I think.
of course, there'd be
You know,
more money, but
It's the
Yeah.
typical. He's used John Dobson ideas with the
that's
PVC and the V notches. Now this was kind of unique. Between the two pieces of plywood there for his azimuth mount, he put an old 33 and a third RPM record, or a couple of them, to act as the
turntable. Wow,
turntable. Yeah.
Yeah, I love this.
that's
Yeah.
great.
I hope it wasn't an old original Beatles album, but
Yeah, maybe.
Pressing of the White Album.
yeah.
Yeah,
Or one of those other
absolutely.
classic ones. And like I said, we get young ladies, middle,
Yeah.
just a whole gamut of people. This is kind of a unique shot.
I remember
Wow.
the last time I was at Nebraska Star Party, and there were whole families that turned out because you guys do a full-on night of educational outreach, and the
Education,
entire
yep.
community pours out for that, and which is really cool. But a lot of people came with their kids and set up their small refractors, and
Yeah.
there were people out there with binoculars. There were people just standing around looking at and amazed at seeing the Milky Way like that.
Oh, yeah, that's the thing. Is just that, the people, that's why we always claim it's a great beginners, first timers, and we hook a lot of them because they start coming back. Then, of course, we get the high end stuff too,
Yes,
and the
Takahashi.
astrometers. Yeah, I was at Takahashi there. Yeah,
Takahashi, yeah. Beautiful.
all set up for some imaging. Here's another shot of the asphalt area that we can set up on with the big Dobsonian. And they get bigger
Yeah.
and bigger.
Oh man, look at that.
Whoa.
I don't remember this. I think it was an 18 or 20 inch, but what was that design? Anybody that it was
that a
like
Ponset?
an off-axis design thing. Yeah.
Yeah.
It's
And then, of course, these guys from Rochester, Minnesota, they bring that thing down.
Wow.
I think it's
That's
a
huge.
I think it's
I
a
think it is.
36
I think it's
inch.
yes, it's near to 1 meter. Yes.
Yeah, 1 meter.
One-
Yep,
one
yep.
meter, 1
Professional
meter.
class apertures, so
Yeah.
that's true.
I remember I visited Peach State Stargaze in the 1999 in Georgia, and I remember that somebody made not so huge telescope, but maybe 70 centimeters. Also 20. I think that was a 25.
Those are big.
Yes, a big,
They're
big.
big. Yeah.
We watched the things was totally amazing. In Georgia, it's not so dark like Nebraska, of course.
Well, you get you start seeing colors. Well, of course, Orion, unless you stay up really late or you get But I've seen pinks in Orion and Lagoon.
Colors.
I've seen pink colors in it. Yeah.
Yeah, absolutely. Yes, it's incredible. This is something that
Naked eye. And also fabulous food and fun. We have a family that comes and caters evening meals, delicious food.
Yeah.
And if you
Wow.
still
I
got
love-
enough energy,
I love
if you got
this.
enough energy during the day, you can go do the tubing down the scenic Niobrara River. You go by some beautiful little waterfalls.
Nice.
beautiful.
Some of them not even. Here's the biggest waterfall in Nebraska, so it's
Yeah.
decent. Part of our education program is the field school, starting with real basics. We push a lot at the people, but we've never had any complaints. They really enjoy that. And then here's another shot from the auditorium at the high school, intermediate
nice.
level school in Valentine with people listening to lectures. It's a beautiful air conditioning
Yes, you have
facility.
a beautiful facilities really for
Other than I wish this was out so people didn't have to drive, but hey, you just have to get in your car and drive drive to town. And then we have like during that day we're in there, swap meets, vendors, we cater pizza in for lunch.
I love that star park. I need to go to Nebraska
someday. Yeah, come on up
someday. Absolutely. Yeah.
Scott, remember this guy?
I do. Sure.
Yeah.
Jeff Norwood.
Yeah, he doesn't come out anymore. It's just gotten too much of a cost and whatever. But that was him and Greta there. Some of these are from a few years ago.
Years. They traveled the United States, going to star party after star party, and providing all kinds of accessories. You can see all the different
stuff,
parts and odds and ends and stuff like that people might have forgotten or we're looking to get a deal on.
He was, we really missed him. He'd usually go to ours either and then go on out to one of them in Washington State or Oregon, spend half time with one and half time with us. So we really enjoyed him. I mentioned solar. Yeah, the kids get a chance to see some solar images and PSTs and safe solar telescopes. Okay, what else we got here? We've been working with the International Dark Sky Association now for a couple of years in collaboration with the Nebraska Game and Parks Commission. We have submitted a proposal to the International Dark Sky Association, IDA, to designate Merritt Reservoir, SRA, as a dark sky sanctuary. We've bumped it up to a sanctuary level. We are hoping to have an answer from them by the time of the star party this next year now, this summer. So specifics for this year, dates July 24th to 29th. Cost $50 adult, 15 children. We're one of the least expensive ones to go to. We kept it that. We made some adjustments. We've had to raise our meal costs and our t-shirt prices, but I still think we have probably the best bang for the buck.
One night having cocktails will, in a couple hours you can blow through that kind of money, no problem.
Yeah. So that's the rundown for this year. Here's our website, and we also are on Facebook.
Yeah.
I see I misspelled early, right?
We know what you mean. There you go.
John.
Yes.
I birth in the 25th of July. I can pass free.
I'm sorry.
My birthday is the 25th of July.
Yours is the 25th of July? Really?
Yeah. I can go free.
There you go. That's right. Mine's the 21st, so I'm too early. Yeah.
Maxi, you are like a kid. You need to give.
So anyway, we hope to have registration open around the 1st.
Yes,
the online registration and
maybe a t-shirt.
Mail in. And so I always try to finish with a little. Yeah, here's one of my favorite little things. Who invented the clouds? In fact, that picture is hanging up here on my wall with all my other memorabilia. So that's it. And I always like this little poem too. The Old Astronomer, which is you see me, that's where I'm getting to be. I guess I've been through the Golden Age, all right?
Well, I think that, John, you've been a steadfast person involved in supporting not only the Nebraska Star Party, but just astronomy in general. I definitely would, raise a glass and give you a special toast, for all the incredible work you've done. And you're always an inspiration. You're always constantly making people aware of the importance of dark skies. And It's a wonderful thing to go out there and hang out with you and experience what astronomy is like with John Johnson. So,
well, thank you so much. And like I said, if we get our, I've been working on the dark sky designation now for probably 8-10 years, at least thinking about it and trying to figure out how we could do it. And we finally got the stars to align, so to speak. And I think we are on the final, track to get this done. And I think that's going to be a big selling point, not only for the Nebraska Star Party, but for what they call astrotourism in the state of Nebraska.
Yeah, it's bragging rights for,
I know the tourism, both the Tourism Commission and the Nebraska Game and Parks people are really pumped to get this done, and they can advertise it too.
That's great. Yeah. That's great. Well, that's
all
wonderful.
Right.
All right. Well, John, thank you for wrapping up the 80th Global Star Party. Maxi and César, thank you so much for bringing on all your wonderful stories and images and the feeling of
well, if it wasn't for you, Scott, I mean, that's it. Here, I've got 2 worldwide friends. I know I got others all around the world, but now because of Scott, I'm a good friend of César and Maxi. If I ever get a chance to come to Argentina, I'm going to look you guys up.
Oh yeah,
it will be a pleasure, John. Really, really.
And you're welcome to come here.
Yeah.
Yes.
Well, thank you.
You can call me, and I go to the airport to ring to this.
Yeah.
And we can go to the Maxi Chivilcoy's city. We go
All
to
right.
the stars. So, yeah, no problem. Yes.
Anytime. Anytime.
We are, for anybody that like to come here to Argentina. Yes.
Yeah. I think once we're all able to travel again, you're going to start to see people coming to Argentina to do some serious astronomy.
I've been to Hawaii a couple times, but other than that, there's only been one time in my life that I've gone south of the equator. So I would love to get back.
Did you get to see good skies when you did that, John?
Yeah, I was when I was in the U.S. Navy out sailing the oceans, and I mean there was dark skies.
It's dark out there.
It was a little hard to have anything big enough to, other than a 750 binocular, because the ship's always moving. But
sure.
But yeah, I was all the way down to the Fiji Islands, so I've seen
excellent
the southern skies once. But,
wonderful. Well, guys, thank you so much, and I want to thank our audience that participated with us. Norm Hughes says thanks for a fun night of fellowship with our friends in astronomy, and you guys are our friends too, and we love it. And any of you that are in the audience that you want to make a presentation on Global Star Party, get in touch with me or any of us at Explore Scientific, and we'll make that arrangement happen. So we'd love to have you. So we will be back on next Tuesday for the 81st Global Star Party. And don't have a theme quite figured out yet, but it's starting to gel. So anyhow, thank you so much. César, Maxi, John, thanks a lot.
Thank you, guys.
Good night.
Everybody take care. We'll see you then. Bye-bye.
Bye-bye.
you